Hello there, and welcome to a gentle journey through the cosmos. Tonight, we're drifting into the peaceful realm of solar systems, where countless worlds spin in quiet harmony across the vast expanse of space. These celestial neighborhoods hold secrets that can calm the mind and spark wonder in equal measure. From planets that dance around twin suns to worlds made entirely of sparkling diamond, the universe has crafted arrangements more beautiful and serene than any earthly garden. If you find comfort in these cosmic explorations, please consider liking this video or sharing your thoughts in the comments below. Your support helps others discover these tranquil moments among the stars. But for now, let your shoulders relax, take a deep breath, and allow yourself to float alongside me through the most soothing facts about solar systems. Let's begin our peaceful voyage into the infinite. The first calming truth about solar systems is their incredible stability. Despite containing objects millions of times more massive than anything on Earth, these cosmic arrangements maintain perfect balance for billions of years. Planets follow their elliptical paths with clockwork precision, never colliding or straying from their designated routes. This celestial choreography has been unfolding since long before life appeared on our planet, and it will continue long after we're gone. There's something deeply reassuring about this cosmic reliability, knowing that even in the vast chaos of space, order and predictability reign supreme. Many solar systems contain planets that orbit in perfect mathematical harmony with one another. These resonant relationships create patterns where one planet completes exactly 2 orbits for every 3 of its neighbor, or 3 orbits for every 5 of another. This synchronization prevents collisions and maintains stability across eons. The gravitational tugs between worlds become a gentle cosmic waltz, rather than a destructive force, with each planet knowing precisely where its companions will be at any given moment. Perhaps one of the most peaceful aspects of solar systems is their patience. Planet formation is a slow, methodical process that unfolds over millions of years. Tiny grains of dust collide and stick together, gradually building larger and larger objects through countless gentle encounters. There's no rushing this cosmic construction project. Each collision adds just a small amount of material, and over vast stretches of time, these accumulations grow into the magnificent worlds we observe today. This unhurried pace of creation reflects the universe's infinite patience and reminds us that the most beautiful things often require time to develop. Some solar systems contain worlds where rain falls not as water, but as precious metals and gemstones. On certain ultra-hot planets, temperatures soar so high that iron and other metals vaporize into the atmosphere. When these metallic clouds drift to cooler regions, they condense and fall as shimmering droplets of liquid metal. Other worlds experience rainfall of tiny glass particles, or even precious stones like rubies and sapphires. While these conditions would be hostile to human life, there's something almost magical about imagining landscapes where treasure literally falls from the sky. The concept of multiple suns gracing the same sky offers another source of cosmic serenity. Binary star systems often host planets that witness 2 sunrises and 2 sunsets each day. These dual stellar companions create ever-changing patterns of light and shadow across planetary surfaces. The interplay between the 2 stars produces complex seasons and lighting conditions that shift in beautiful, predictable cycles. Imagine standing on such a world and watching one sunset, while another continues to illuminate the landscape in warm, golden hues. Solar systems demonstrate remarkable diversity in their planetary compositions. Some worlds are made almost entirely of water, existing as global oceans with no continents whatsoever. These water worlds may harbour vast underwater ecosystems, completely unlike anything on Earth. The constant motion of their planet-wide oceans creates gentle currents that circulate nutrients and maintain stable temperatures across their surfaces. The rhythmic sound of waves would be a constant companion on such worlds, providing nature's own white noise across entire planetary surfaces. Other solar systems contain planets composed primarily of carbon in its crystalline form. These diamond worlds sparkle with an inner light, their surfaces reflecting starlight in brilliant displays of natural beauty. The immense pressures required to create such worlds transform ordinary carbon into structures more valuable than any earthly treasure vault. While we could never walk upon such surfaces, the mere existence of entire planets made of diamonds speaks to the universe's capacity for creating wonders beyond our wildest imagination. The protective nature of gas giant planets provides another source of cosmic comfort. These massive worlds often serve as cosmic vacuum cleaners, using their powerful gravitational fields to capture asteroids and comets that might otherwise threaten smaller, rocky planets. Jupiter has been performing this guardian role for our solar system throughout Earth's history, deflecting countless potentially dangerous objects away from our planet. This celestial protection system operates silently and continuously, allowing life to flourish on worlds that might otherwise face constant bombardment. Many solar systems contain vast clouds of comets in their outer regions, creating reservoirs of water and organic materials that can be delivered to inner planets when needed. These comet clouds represent cosmic seed banks, storing the ingredients for life in frozen form until orbital mechanics brings them closer to their parent stars. The gentle gravitational nudges that occasionally send comets inward ensure that water and other essential compounds remain available throughout a solar system's lifetime. The magnetic fields generated by many planets create invisible shields that protect their atmospheres from harmful stellar radiation. These planetary magnetospheres deflect charged particles from their parent stars, allowing atmospheres to remain intact for billions of years. The interaction between these magnetic fields and stellar winds creates beautiful auroras that dance across polar skies in displays of natural artistry. These light shows represent the planet's quiet defense against cosmic forces, transforming potentially destructive energy into breathtaking beauty. Some solar systems maintain such perfect conditions that their planets can support liquid water on their surfaces for billions of years. These worlds exist in what astronomers call habitable zones, where temperatures remain stable enough for water to exist in all three phases. The delicate balance required for such conditions to persist demonstrates the universe's ability to create and maintain environments suitable for life. The fact that potentially millions of such worlds exist throughout our galaxy suggests that the cosmos actively nurtures the conditions necessary for biological processes to unfold. The recycling nature of solar systems provides another source of cosmic peace. When massive stars eventually exhaust their fuel and explode as supernovas, they scatter heavy elements throughout space. These materials become the building blocks for new generations of stars and planets, ensuring that the universe continuously creates new opportunities for complexity and beauty to emerge. Nothing in the cosmos is ever truly lost, merely transformed into new arrangements and possibilities. Tidal forces between planets and their moons create gentle rhythms that can persist for billions of years. These gravitational interactions produce predictable patterns of heating and cooling that may drive geological activity and maintain liquid oceans beneath icy surfaces. The constant flexing caused by tidal forces represents a form of cosmic massage that keeps planetary interiors active and potentially habitable. This ongoing process demonstrates how gravitational relationships can nurture rather than destroy. The vast scales of solar systems ensure that even dramatic events unfold slowly from human perspectives. Planetary migrations that reshape entire solar system architectures occur over millions of years, allowing ample time for adaptation and adjustment. Changes that might seem catastrophic on human timescales become gentle evolutionary processes when viewed across cosmic time. This perspective reminds us that the universe operates on scales that dwarf our daily concerns, and that cosmic processes unfold with infinite patience. Some planets maintain such thick atmospheres that their surfaces remain warm and comfortable despite orbiting far from their parent stars. These super-Earth worlds demonstrate how atmospheric composition can create habitable conditions across a much wider range of distances than previously thought possible. The greenhouse effects created by these dense atmospheres trap stellar energy efficiently, creating stable climates that could support liquid water and potentially life. The existence of Trojan asteroids that share planetary orbits without causing disruption illustrates another form of cosmic harmony. These small bodies follow the same path as larger planets, but remain trapped in gravitationally stable regions that prevent collisions. They travel as cosmic companions, sharing the journey around their parent star, while maintaining respectful distances. This arrangement shows how the universe can accommodate multiple objects in the same general space through elegant gravitational solutions. As we continue to explore the peaceful aspects of solar systems, we discover that the cosmos operates more like a vast, gentle symphony than a chaotic battlefield. Each component knows its place and role in the larger composition, contributing to an overall harmony that spans billions of years. This cosmic music plays on scales both grand and intimate, from the orbital periods of planets to the rotation rates of individual worlds. The gentle rotation of planets creates another source of cosmic tranquility. Most worlds spin with remarkable consistency, maintaining their rotational periods for billions of years. This steady rhythm gives rise to predictable day-night cycles that govern the flow of energy across planetary surfaces. The regularity of these cycles creates natural metronomes that beat in harmony with the larger orbital dance. Even planets that rotate very slowly, taking weeks or months to complete a single turn, maintain their unhurried pace with clockwork precision. Within many solar systems, we find worlds where the very air seems to breathe with calm purpose. Planets with thick atmospheres often develop circulation patterns that distribute heat evenly across their surfaces, preventing extreme temperature variations that might disrupt stability. These atmospheric currents flow in predictable patterns, creating weather systems that cycle through their phases like gentle, planetary scale breathing. The movement of air and clouds becomes a form of planetary meditation, constantly redistributing energy to maintain balance. The formation of planetary rings represents one of nature's most serene architectural achievements. These delicate structures consist of countless small particles orbiting in perfect formation, creating bands of material that can persist for millions of years. Each particle follows its own precise orbit while contributing to the overall pattern. The result resembles cosmic jewelry, with rings that catch and scatter starlight in ethereal displays. Some ring systems are so thin they would be nearly invisible from the side, yet they maintain their elegant structure across vast distances. Many solar systems contain worlds where seasons unfold over decades or even centuries, creating environments where change occurs at an almost geological pace. These extended seasonal cycles allow ecosystems and atmospheric conditions to develop and mature slowly, without the rapid fluctuations that might disrupt delicate processes. The gradual transitions between seasons create opportunities for complex patterns to emerge and stabilize over long periods. Life on such worlds, if it exists, would experience change as a gentle, almost imperceptible drift, rather than sudden shifts. The gravitational relationships between multiple planets often create stable configurations that can endure for the entire lifetime of their parent star. These arrangements, known as planetary systems in resonance, demonstrate how celestial mechanics naturally seeks harmony. When planets settle into these resonant patterns, they essentially lock into a cosmic dance where each world's position influences and stabilizes the others. The mathematical beauty of these relationships reveals an underlying order that emerges from the simple laws of gravity and motion. Some solar systems host worlds where the boundary between day and night creates permanent twilight zones. These regions, neither fully illuminated nor completely dark, maintain constant, gentle lighting conditions that never change. The soft illumination in these areas provides just enough energy to drive atmospheric processes while avoiding the extremes of blazing heat or frozen darkness. Such zones might represent some of the most peaceful environments in the universe, where conditions remain eternally mild and stable. The protective bubbles created by stellar magnetic fields extend far beyond individual planets, encompassing entire solar systems in invisible shields. These vast magnetic structures deflect harmful cosmic radiation, creating safe havens where delicate atmospheric and surface processes can proceed undisturbed. The boundaries of these magnetic bubbles mark the transition from the gentle environment within a solar system to the harsher conditions of interstellar space. This cosmic protection operates continuously and silently, requiring no maintenance or intervention. Many worlds maintain subsurface oceans that remain liquid for billions of years, insulated beneath protective layers of ice or rock. These hidden seas represent some of the most stable environments imaginable, shielded from surface temperature variations and cosmic radiation. The darkness and isolation of these buried oceans might seem forbidding, but they offer unprecedented stability for any processes that might unfold within them. The pressure and temperature conditions in these environments remain remarkably constant across geological time. The slow cooling of young planets creates extended periods of gentle warmth that can last for hundreds of millions of years. During these phases, worlds gradually release the heat from their formation, maintaining comfortable surface temperatures, even at distances where starlight alone would leave them frozen. This internal heating provides a buffer against the cold of space, creating extended opportunities for surface processes to operate. The gradual nature of this cooling ensures that changes occur slowly enough to allow adaptation and evolution. Some solar systems contain worlds where gravity is so gentle that atmospheres can extend far into space, creating diffuse cloud-like envelopes around entire planets. These extended atmospheres interact with stellar radiation in complex ways, producing aurora-like phenomena that can encompass entire hemispheres. The low gravity allows atmospheric particles to move in slow, graceful patterns that would be impossible on higher mass worlds. The result is a kind of planetary halo that shimmers and flows with ethereal beauty. The orbital mechanics of binary planet systems create tidal patterns of extraordinary complexity and beauty. When two worlds of similar size orbit around their common center of gravity, they raise tides on each other's surfaces that follow intricate mathematical patterns. These gravitational interactions produce rhythms within rhythms, creating tidal cycles that might repeat over periods of days, months, or even years. The resulting patterns demonstrate how simple physical laws can generate complexity that borders on artistry. Many solar systems maintain such stable conditions that their planetary arrangements have remained essentially unchanged for billions of years. These ancient configurations serve as cosmic monuments to the power of gravitational harmony. The fact that arrangements of worlds can persist across such vast spans of time speaks to the fundamental stability that emerges when celestial mechanics finds its natural balance. In these systems, the passage of billions of years brings only minor adjustments rather than dramatic reorganizations. The way stellar light interacts with planetary atmospheres creates optical phenomena of stunning beauty and consistency. Rayleigh scattering produces blue skies on worlds with Earth-like atmospheres, while different atmospheric compositions give rise to skies of amber, crimson, or even green. These colors remain constant features of each world, providing reliable visual signatures that persist across geological ages. The physics of light scattering ensures that these atmospheric displays follow predictable patterns based on the molecular composition of each planet's air. Some worlds experience such gentle stellar radiation that their atmospheres can support complex photochemical processes without the violent reactions that occur closer to their parent stars. These moderate energy environments allow atmospheric chemistry to unfold at a measured pace, building complex molecules through gradual processes rather than high-energy collisions. The resulting atmospheric compositions can achieve remarkable stability, maintaining their chemical balance for millions or billions of years without dramatic shifts. The existence of shepherd moons demonstrates how gravitational relationships can maintain order within chaotic environments. These small satellites use their modest gravitational influence to keep ring particles organized, preventing them from spreading out or clumping together destructively. The shepherd moons patrol the edges of ring systems like cosmic gardeners, gently nudging wayward particles back into their proper orbits. This natural maintenance system operates continuously, preserving the delicate beauty of ring structures across cosmic time. Within the quieter regions of solar systems, dust particles follow orbits so stable that they can persist for millions of years without significant disturbance. These microscopic grains trace out elegant elliptical paths, occasionally catching starlight to create zodiacal light displays visible from planetary surfaces. The dust represents the gentle remnants of ancient collisions and the slow erosion of larger bodies, creating a fine cosmic snow that falls perpetually through the emptiness between worlds. Each grain carries within it the history of its parent body, preserving information about conditions that existed eons ago. The thermal equilibrium achieved by many planets creates environments where temperature variations remain within narrow, stable ranges for geological ages. This thermal stability arises from the careful balance between incoming stellar radiation, internal heat sources, and atmospheric heat distribution. Once established, these thermal patterns can persist virtually unchanged, providing consistent environmental conditions that span billions of years. The reliability of these thermal regimes creates predictable environments where complex processes can unfold without disruption from extreme temperature swings. As we drift deeper into the serene mechanics of solar systems, we encounter worlds where the very concept of catastrophic change becomes almost meaningless. These systems have achieved such profound stability that their fundamental characteristics remain constant across time periods that dwarf the entire history of complex life on Earth. In these cosmic havens, change occurs so gradually that it becomes indistinguishable from eternal constancy, creating environments where the universe reveals its capacity for infinite patience and enduring beauty. During beauty, the gentle giants of our galaxy reveal themselves in solar systems where massive planets serve as cosmic protectors, their immense gravitational fields sweeping up dangerous debris that might otherwise threaten smaller worlds. These guardian planets perform their duties silently, clearing orbital paths of asteroids and comets with the patience of eternal centuries. Their presence creates zones of safety where delicate atmospheric processes can unfold, undisturbed by the chaos of cosmic bombardment. In the outer reaches of many solar systems, vast spherical clouds of icy objects drift in slow, stately orbits that take millions of years to complete. These distant reservoirs contain the frozen building blocks of worlds, preserving water and organic compounds in pristine condition across eons. The extreme cold of these regions acts as a cosmic freezer, maintaining these materials in perfect storage until gravitational nudges occasionally send them sunward to nourish inner planets. Some worlds achieve such perfect atmospheric balance that their skies maintain constant, gentle breezes that have blown in the same patterns for billions of years. These planetary wind systems create natural air conditioning on a global scale, distributing heat from warm regions to cool ones with clockwork efficiency. The resulting climate stability provides environments where temperature variations remain within comfortable ranges, regardless of seasonal changes or solar fluctuations. The magnetic dynamos operating deep within planetary cores generate invisible force fields that extend far into space, creating protective magnetospheres that deflect harmful cosmic radiation. These natural shields operate continuously without any external power source, drawing their energy from the slow convection of molten metals in planetary interiors. The boundaries where these magnetic fields meet stellar winds create regions of enhanced beauty, where charged particles spiral along field lines to produce auroral displays of breathtaking elegance. Many solar systems contain worlds where surface water exists in perfect liquid form for billions of years. never freezing solid or boiling away despite the gradual evolution of their parent stars. This remarkable stability arises from atmospheric feedback mechanisms that automatically adjust to maintain optimal temperatures. As stellar brightness slowly increases over geological time, planetary atmospheres respond by reducing their greenhouse gas concentrations, preserving habitable conditions through self-regulating processes. The gravitational resonances between multiple moons create tidal patterns of extraordinary mathematical beauty. When several satellites orbit a planet in precise numerical relationships, their combined gravitational influence produces tidal cycles that repeat in complex but predictable patterns. These celestial clockworks demonstrate how simple physical laws can generate rhythms of stunning complexity, creating environments where the very ground rises and falls in harmony with cosmic mechanics. Some planets rotate so slowly that their day-night cycles unfold over periods equivalent to Earth months or even years. This leisurely pace of rotation allows surface temperatures to equilibrate gradually, preventing the extreme contrasts that rapid rotation might create. The extended daylight periods provide ample time for atmospheric circulation to distribute solar energy evenly, while the long nights allow heat to radiate away slowly and gently. Within certain solar systems, dust grains follow such stable orbits that they form vast, disc-shaped structures that persist for millions of years. These debris disks catch and scatter starlight, creating faint glows that extend far beyond the outermost planets. The particles within these structures follow orderly patterns, neither clumping together destructively nor dispersing into empty space, instead maintaining a delicate balance that preserves their ethereal beauty across cosmic ages. The way planetary atmospheres interact with their parent stars creates natural thermostats that maintain stable surface conditions despite variations in stellar output. When stellar radiation increases, atmospheric molecules respond by reflecting more light back to space, or by initiating chemical reactions that absorb excess energy. Conversely, during periods of reduced stellar brightness, these same atmospheric processes adjust to retain more heat, ensuring that surface temperatures remain within narrow, life-friendly ranges. Many worlds develop such thick atmospheric blankets that their surfaces remain comfortably warm, even at distances where naked rock would freeze solid. These super greenhouse planets demonstrate how atmospheric composition can extend habitable zones far beyond their traditional boundaries. The dense air on these worlds creates pressure cooker effects that maintain liquid water across their entire surfaces, turning them into global hot springs that never cool below comfortable temperatures. The orbital dance of Trojan asteroids reveals another form of cosmic harmony, where small bodies share planetary orbits without ever approaching close enough to cause collisions. These cosmic hitchhikers remain trapped in gravitationally stable regions that lead or follow major planets by precisely 60 degrees, creating triangular formations that persist for millions of years. The mathematical elegance of these arrangements demonstrates how gravitational forces naturally organize matter into stable, beautiful patterns. Some solar systems contain binary planets where two worlds of similar size orbit around their mutual center of gravity, creating environments where each world dominates the other's sky. These cosmic twins raise spectacular tides on each other's surfaces while maintaining orbital stability through their perfectly balanced gravitational embrace. The interplay between their gravitational fields creates complex tidal rhythms that follow intricate mathematical sequences, producing natural metronomes that beat in harmony with celestial mechanics. The internal heat sources within many planets provide gentle, consistent warmth that can persist for billions of years after their formation. Radioactive decay deep within planetary cores releases energy at such a steady rate that surface temperatures remain stable despite the gradual cooling of outer layers. This internal heating acts as a cosmic furnace that never requires refueling, maintaining comfortable conditions on worlds that might otherwise freeze in the cold of space. Certain atmospheric compositions create natural light shows, where molecular interactions with stellar radiation produce gentle glows that illuminate entire planetary hemispheres. These phenomena occur when atmospheric gases absorb ultraviolet light and re-emit it at visible wavelengths, creating soft, persistent illumination that supplements direct starlight. The resulting glow provides enough light to power photochemical processes while avoiding the harsh intensities that might damage delicate surface materials. The way water vapor circulates through planetary atmospheres creates global weather systems that operate like vast, gentle breathing mechanisms. Evaporation from warm ocean regions carries moisture to cooler areas where it condenses and falls as precipitation, creating cycles that redistribute both heat and water across planetary surfaces. These circulation patterns establish themselves early in a planet's history and can continue operating with remarkable consistency for billions of years. Some worlds maintain such perfect chemical balance in their atmospheres that reactive gases like oxygen and methane coexist without destroying each other through rapid chemical reactions. This atmospheric equilibrium requires constant replenishment of these gases through biological or geological processes, creating environments where the very air serves as evidence of ongoing planetary activity. The delicate balance required to maintain such atmospheric compositions demonstrates the sophisticated regulatory mechanisms that can emerge in mature planetary systems. The magnetic field interactions between planets and their moons create regions of enhanced particle trapping that produce persistent auroral displays far more spectacular than anything seen on Earth. These magnetic coupling effects channel charged particles along field lines that connect planetary and satellite magnetospheres, creating light bridges that span the space between worlds. The resulting auroras can persist for days or weeks, painting the space between planets with curtains of colored light. Many solar systems achieve such orbital precision that their planetary alignments repeat in exact mathematical patterns over periods of thousands or millions of years. These grand conjunctions create gravitational configurations that repeat like clockwork, demonstrating the underlying mathematical order that governs celestial mechanics. The predictability of these alignments allows for the calculation of planetary positions across vast spans of time, revealing the deterministic beauty of gravitational interactions. The thermal inertia of massive planets creates climate stability that buffers against short-term variations in stellar output. When parent stars experience periods of increased or decreased brightness, large planetary masses respond so slowly to temperature changes that surface conditions remain virtually constant. This thermal buffering effect protects atmospheric and surface processes from disruption, allowing complex systems to develop and persist despite stellar variability. Some worlds develop atmospheric layers so perfectly stratified that different altitudes maintain distinct, stable chemical compositions for millions of years. These atmospheric gradients create vertical zones where specific chemical processes occur at their optimal altitudes, resulting in planetary atmospheres that function like vast natural chemical factories. The stability of these stratified systems allows for the development of complex atmospheric chemistry that might support intricate molecular processes. The gravitational focusing effects of massive planets can concentrate cosmic dust and small debris into narrow streams that follow predictable orbital paths. These focused streams create meteor showers that occur with clockwork regularity, delivering small amounts of extraterrestrial material to planetary surfaces in gentle, predictable doses. Rather than chaotic bombardments, these focused delivery systems provide steady, manageable influxes of cosmic material that can enrich planetary surfaces without causing destruction. Within the quiet regions between planetary orbits, gravitational null points create zones where small objects can remain stationary relative to larger bodies for extended periods. These Lagrange points serve as cosmic parking spaces where natural satellites or artificial structures could maintain stable positions without requiring energy for station keeping. The mathematical elegance of these gravitational balance points demonstrates how celestial mechanics naturally creates regions of enhanced stability. The way stellar radiation pressure interacts with planetary magnetic fields creates natural particle accelerators that operate continuously in the space around magnetized worlds. These acceleration regions channel charged particles into highly organized streams that follow magnetic field lines with remarkable precision. The resulting particle flows create structured radiation environments that remain stable for millions of years, forming invisible highways for cosmic charged particles. Many planetary ring systems demonstrate self-organizing properties, where gravitational and electromagnetic forces naturally sort particles by size and composition. This cosmic sorting process creates rings with distinct boundaries and characteristics, each optimized for particles of specific properties. The self-maintaining nature of these systems ensures that ring structures can persist and even repair themselves after minor disruptions, preserving their beauty across geological timescales. Some solar systems contain worlds where the interaction between planetary rotation and atmospheric circulation creates permanent storm systems that maintain their structure for centuries or millennia. These persistent weather features demonstrate how atmospheric dynamics can achieve stable, long-lasting patterns under the right conditions. The storms serve as atmospheric engines that help distribute energy and maintain global climate stability, while creating spectacular displays of natural power operating in perfect balance. The way tidal forces from multiple gravitational sources can constructively interfere creates regions of enhanced heating that maintain liquid water in environments that would otherwise freeze solid. When several massive bodies align their tidal influences, the combined effect can generate sufficient internal heating to sustain subsurface oceans or surface hot springs. These tidal heating zones provide oases of warmth in otherwise frigid environments, creating pockets of potential habitability in unexpected locations. As we continue our gentle exploration through these cosmic neighborhoods, we discover that the universe operates more like a vast symphony than a collection of random objects. Each component contributes its own voice to an overall harmony that spans billions of years and countless light years of space. The mathematical precision underlying these cosmic arrangements reveals an order so profound that it transforms our understanding of what stability and beauty mean on truly cosmic scales. Scales. The gentle embrace of planetary atmospheres creates some of the most soothing phenomena in the cosmos. When starlight filters through layers of atmospheric gases, it undergoes a transformation that paints entire worlds in soft, consistent hues. The physics of light scattering ensures that each planet develops its own signature color palette, from the familiar blues of Earth-like atmospheres to the golden ambers of methane-rich skies. These atmospheric filters work tirelessly, day and night, creating natural lighting that remains constant for millions of years. Within many solar systems, we find worlds where crystalline formations occur on scales that dwarf anything found on Earth. Entire planetary crusts can be composed of mineral structures that form geometric patterns visible from space. These crystal worlds develop through slow cooling processes that allow atoms to arrange themselves in perfect lattices spanning thousands of kilometers. The resulting surfaces reflect starlight in ways that create shimmering displays of natural architecture, where each facet catches and redirects light according to mathematical principles of crystal optics. The way some planets maintain perfect rotational stability creates environments where the concept of seasons becomes a gentle, predictable rhythm rather than dramatic change. These worlds achieve rotational equilibrium through the gravitational influence of large moons or the tidal effects of binary companions. Once established, this stability can persist for billions of years, creating climates where temperature variations follow smooth, sinusoidal curves that never produce shocking extremes. Life on such worlds would experience change as a gentle breathing pattern, rather than sudden shifts. Many solar systems contain debris fields that have achieved such perfect gravitational balance that they remain stable for geological ages. These cosmic gardens consist of countless small objects that follow precisely calculated orbits, creating three-dimensional sculptures of matter and motion that persist across eons. The mathematical beauty of these arrangements demonstrates how gravitational forces naturally organize matter into stable, aesthetically pleasing patterns. Each particle knows its place in the larger design, contributing to an overall harmony that emerges from simple physical laws. The magnetic field interactions between multiple planets can create regions where charged particles follow helical paths of extraordinary mathematical elegance. When planetary magnetospheres overlap or interact, they generate complex field geometries that guide particle motion in spiraling trajectories. These invisible highways channel cosmic radiation along predictable routes, creating structured environments where electromagnetic forces operate like cosmic traffic control systems. The resulting particle flows establish themselves early in a system's history and can maintain their organization for millions of years. Some worlds develop atmospheric circulation patterns so stable that wind systems blow in the same directions for billions of years. These persistent circulation cells arise from the interaction between planetary rotation, atmospheric heating, and topographic features. Once established, these wind patterns become self-reinforcing, creating global air currents that redistribute heat and moisture with clockwork reliability. The consistency of these atmospheric motions provides predictable weather patterns that change only on geological timescales. The way certain planetary cores generate heat through radioactive decay creates internal energy sources that operate like cosmic slow-burning furnaces. These natural reactors release energy at such steady rates that they can maintain planetary temperatures for billions of years without any external fuel source. The gradual decay of radioactive elements provides a reliable baseline of warmth that supplements stellar heating, creating environments where surface conditions remain stable despite variations in solar output. Many solar systems achieve such perfect mass distribution that their gravitational fields create natural focusing effects for incoming cosmic radiation. These gravitational lenses concentrate or disperse energy in ways that create regions of enhanced or reduced radiation intensity. The focusing effects operate continuously and automatically, creating radiation environments that remain stable across cosmic time. These natural radiation management systems demonstrate how gravitational fields can serve protective functions beyond simply maintaining orbital stability. The formation of planetary ring systems reveals nature's ability to create structures of stunning mathematical precision from chaotic initial conditions. When moons or asteroids venture too close to massive planets, tidal forces gently tear them apart and redistribute their material into perfectly circular bands. The resulting rings organize themselves according to strict physical laws, with each particle settling into the orbit that minimizes gravitational stress. This natural sorting process creates ring systems that can maintain their structure for millions of years, while continuously reshaping themselves in response to minor perturbations. Some worlds maintain such perfect atmospheric pressure that liquid water can exist across their entire surfaces without ever freezing or boiling. These Goldilocks planets achieve atmospheric compositions that create just the right amount of greenhouse warming to maintain comfortable temperatures at all latitudes. The atmospheric pressure on these worlds remains within the narrow range that allows water to exist in its liquid phase, creating global environments where ocean chemistry can operate without phase transitions that might disrupt delicate processes. The way stellar radiation interacts with planetary magnetic fields creates natural particle accelerators that operate with remarkable efficiency and stability. These cosmic accelerators channel charged particles along magnetic field lines, accelerating them to high velocities through electromagnetic interactions. The acceleration process occurs continuously and automatically, creating streams of energetic particles that follow predictable trajectories through space. These natural accelerators demonstrate how electromagnetic forces can create organized, high-energy environments without any technological intervention. Many planetary satellites develop orbital relationships so precisely tuned that they create gravitational resonances spanning multiple moons simultaneously. These complex resonant chains lock entire satellite systems into synchronized motion, where the orbital periods of different moons relate to each other through exact mathematical ratios. The resulting gravitational choreography ensures that close encounters between satellites occur only at safe distances and predictable intervals, preventing collisions while maintaining orbital stability across geological time. The thermal regulation systems that develop on many worlds operate through feedback mechanisms so sophisticated that they automatically adjust to maintain optimal surface temperatures. When solar heating increases, these natural thermostats respond by increasing cloud cover or altering atmospheric composition to reflect more incoming radiation. Conversely, when stellar output decreases, the same systems adjust to retain more heat, ensuring that surface temperatures remain within narrow ranges despite external variations. Some solar systems contain worlds where the interaction between rotation and magnetic fields creates global electromagnetic dynamos that generate power continuously for billions of years. These planetary generators operate through the motion of conducting fluids in planetary interiors, creating electrical currents that maintain strong magnetic fields. The energy for these dynamos comes from the rotational energy of the planet itself, ensuring that magnetic field generation can continue as long as the world continues to spin. The way cosmic dust settles into stable orbital configurations creates vast, disk-shaped structures that can persist for millions of years without significant change. These dust disks organize themselves through gravitational and electromagnetic forces, forming geometric patterns that remain stable despite the constant addition of new material from asteroid collisions and comet evaporation. The self-organizing properties of these dust systems demonstrate how matter naturally arranges itself into aesthetically pleasing configurations when given sufficient time and space. Many planets develop subsurface ocean systems that remain liquid for billions of years through tidal heating mechanisms that operate with clockwork regularity. The gravitational flexing caused by orbital motion generates internal friction that produces steady heat flow, maintaining subsurface seas at comfortable temperatures despite surface conditions that might be frozen or scorching. These hidden oceans represent some of the most stable aquatic environments in the universe, protected from surface variations and cosmic radiation. The gravitational interactions between binary star systems and their planets create orbital dynamics of extraordinary mathematical beauty and stability. Planets in these systems follow complex trajectories that loop around both stars or remain bound to individual stellar components. Despite the apparent complexity of these orbital arrangements, they often achieve remarkable long-term stability through gravitational balancing effects that prevent close encounters or ejection events. Some worlds achieve such perfect chemical equilibrium in their atmospheres that reactive gases coexist in stable ratios for geological ages. This atmospheric balance requires continuous replenishment through geological or biological processes that operate at precisely the rates needed to maintain chemical stability. The resulting atmospheric compositions create environments where complex chemistry can proceed without being disrupted by rapid oxidation or reduction reactions. The way planetary auroras develop into persistent structured displays reveals the underlying order within electromagnetic interactions between worlds and their parent stars. These light shows follow predictable patterns based on magnetic field configurations and solar wind conditions, creating natural illumination systems that can persist for days, weeks, or even months. The mathematical precision of auroral displays demonstrates how electromagnetic forces create beauty through organized particle interactions. Many solar systems contain gravitational anomalies where the combined effects of multiple massive bodies create regions of enhanced stability for smaller objects. These gravitational sweet spots allow asteroids, comets, or even small moons to remain in stable positions for millions of years without requiring course corrections. The mathematical elegance of these stable regions shows how complex gravitational systems naturally create zones of enhanced order and predictability. The thermal stratification that develops in many planetary atmospheres creates distinct layers where different chemical processes occur at their optimal altitudes and temperatures. These atmospheric zones establish themselves early in planetary history and can maintain their structure for billions of years, creating stable environments where specific molecular reactions proceed at steady rates. The layered organization of these atmospheres demonstrates how thermal gradients naturally sort chemical processes according to their energy requirements. Some planets develop rotation rates so perfectly synchronized with their orbital periods that they maintain constant orientations relative to their parent stars. This tidal locking creates worlds where one hemisphere experiences eternal day, while the other remains in perpetual night, with twilight zones between them where temperatures remain moderate and stable. The precision of this synchronization ensures that these thermal patterns persist unchanged for billions of years. The way stellar radiation pressure sorts cosmic dust particles by size and composition creates natural classification systems that organize matter according to physical properties. Smaller particles respond more strongly to radiation pressure and migrate to different orbital distances than larger grains, creating zones where particles of similar characteristics concentrate. This cosmic sorting process operates continuously, maintaining organized dust distributions that persist for millions of years. Many worlds develop magnetic field configurations that create natural laboratories where charge-particle interactions can be studied across cosmic scales. These planetary magnetospheres trap and organize cosmic radiation in ways that reveal the fundamental properties of electromagnetic fields and particle dynamics. The stability of these magnetic environments ensures that particle interactions follow consistent patterns that remain observable across geological timespans. The gravitational resonances between planets and asteroid belts create clearance mechanisms that maintain organized distributions of small bodies throughout solar systems. These resonant relationships prevent asteroids from accumulating in regions where they might destabilize planetary orbits, instead shepherding them into stable zones where they can persist without causing disruption. The mathematical precision of these clearance mechanisms demonstrates how gravitational interactions naturally organize matter into stable, non-threatening configurations. Some atmospheric circulation systems develop such perfect efficiency that they transport heat from warm regions to cold areas with minimal energy loss. These global circulation cells operate like planetary heat engines, using temperature differences to drive atmospheric motion that redistributes thermal energy across entire worlds. The thermodynamic efficiency of these systems ensures that temperature gradients remain moderate and that climate stability persists across geological ages. The way multiple moons interact gravitationally can create tidal heating patterns that maintain liquid water reservoirs beneath icy surfaces for billions of years. When several satellites orbit a planet in resonant configurations, their combined gravitational influence generates complex tidal cycles that produce steady heat flow through friction and flexing. These multi-body tidal systems operate with remarkable consistency, providing reliable energy sources that can sustain subsurface oceans across cosmic time. Many solar systems achieve such perfect orbital spacing that planetary gravitational fields create natural barrier systems, preventing close encounters between worlds. These gravitational barriers operate through mathematical principles that ensure approaching bodies are deflected into safe trajectories before collisions can occur. The precision of these deflection mechanisms demonstrates how gravitational interactions naturally protect planetary systems from catastrophic disruption. The magnetic field interactions between planets and their ring systems create electromagnetic environments where charged particles follow organized, predictable paths for millions of years. These structured electromagnetic fields channel cosmic radiation along specific trajectories, creating regions where particle densities and energy distributions remain stable across geological time. The resulting electromagnetic architectures demonstrate how magnetic forces can create persistent, organized structures in space. Some worlds develop atmospheric compositions so perfectly balanced that they create natural optical effects resembling stained glass windows spanning entire hemispheres. When sunlight interacts with precisely tuned mixtures of atmospheric gases, it produces spectral filtering effects that bathe planetary surfaces in colored light that remains constant for millions of years. These natural light filters create environments where illumination quality stays consistent despite variations in stellar output or atmospheric circulation. The thermal coupling between planetary cores and surfaces creates heat distribution systems that operate with the reliability of cosmic central heating. Deep radioactive decay and residual formation, heat flow outward through planetary interiors at steady rates, maintaining surface temperatures within narrow ranges, regardless of external heating variations. These internal heating systems provide thermal stability that can persist for billions of years, creating environments where surface processes proceed without disruption from temperature extremes. As our gentle journey through these cosmic neighborhoods continues, we find ourselves surrounded by evidence of the universe's profound capacity for creating and maintaining order on the grandest possible scales. The mathematical precision underlying these stellar arrangements reveals that beauty and stability are not accidents, but natural consequences of physical laws operating across cosmic time and space. In these serene celestial environments, we discover that the cosmos operates more like an infinite symphony of gravitational harmony than a chaotic collection of random objects hurtling through emptiness. Ines. The delicate interplay between stellar evolution and planetary stability creates some of the most reassuring patterns in our universe. As parent stars gradually brighten over billions of years, many worlds respond by automatically adjusting their atmospheric compositions to maintain perfect surface temperatures. These natural feedback systems operate so smoothly that liquid water can persist on planetary surfaces throughout the entire main sequence lifetime of their host stars. The precision of these atmospheric adjustments demonstrates how nature builds automatic climate control into planetary systems. Within the quieter regions of space, we find solar systems where dust particles follow such orderly paths that they create geometric patterns spanning millions of kilometers. These cosmic mandalas form when gravitational forces organize debris into symmetrical arrangements that persist for geological ages. The mathematical beauty of these dust patterns reveals itself most clearly when viewed from above the orbital plane, where the underlying geometric relationships become apparent as spirals, rings, and radial structures that maintain their form across eons. Some worlds develop such perfectly balanced day-night cycles that their atmospheric circulation systems establish permanent trade wind patterns that blow steadily for billions of years. These global wind systems create predictable weather patterns where storms follow regular paths and seasonal changes occur with clockwork precision. The consistency of these circulation patterns ensures that climate zones remain stable, allowing complex atmospheric chemistry to develop and persist without disruption from chaotic weather variations. The way gravitational microlensing effects focus starlight creates natural telescopes that can magnify distant cosmic phenomena for extended observation periods. When massive planets align precisely with background stars, their gravitational fields bend light rays to create temporary magnification effects that last for weeks or months. These cosmic lenses operate according to Einstein's general relativity, demonstrating how space and time curvature can enhance our ability to observe distant astronomical objects through purely natural processes. Many planetary ring systems develop shepherd moon configurations that maintain ring particle organization through gentle gravitational nudges rather than violent collisions. These small satellites patrol ring edges like cosmic gardeners, using their modest gravitational influence to keep particles properly distributed. The shepherding process operates so efficiently that ring systems can self-repair after minor disruptions, automatically redistributing particles to maintain optimal spacing and density throughout the ring structure. The thermal properties of certain planetary materials create natural greenhouse effects that operate within precise temperature ranges for billions of years. When atmospheric gases achieve optimal concentrations, they trap just enough stellar radiation to maintain comfortable surface conditions while preventing runaway heating that might destabilize climate systems. These natural thermostats adjust automatically to changes in stellar output, ensuring that planetary temperatures remain within narrow bands suitable for complex chemistry. Some solar systems contain worlds where crystalline mineral formations create natural prisms that split sunlight into rainbow displays visible across entire continents. These geological light shows occur when specific crystal structures form on planetary surfaces and achieve orientations that interact optimally with incoming stellar radiation. The resulting spectral displays create landscapes where colored light dances across mineral formations, producing natural light symphonies that persist as long as the crystal structures remain intact. The way planetary magnetic fields interact with charged particle streams creates electromagnetic environments where aurora displays can persist continuously for centuries. When stellar wind conditions remain stable and planetary magnetic configurations maintain consistent orientations, these light shows establish themselves as permanent atmospheric features. The mathematical precision of these electromagnetic interactions ensures that auroral patterns follow predictable cycles based on solar activity and magnetic field geometry. Many worlds achieve such perfect atmospheric pressure gradients that sound waves propagate with enhanced clarity and musical quality. These acoustic environments arise when atmospheric density varies smoothly with altitude, creating natural sound transmission systems that can carry audio signals across vast distances without distortion. The acoustic properties of these atmospheres might allow for communication across entire continents through atmospheric resonance effects that amplify and clarify transmitted sounds. The gravitational resonances between multiple planetary satellites create tidal patterns that generate steady, rhythmic heating cycles lasting for millions of years. When moons achieve precise orbital relationships, their combined gravitational influence produces tidal flexing that maintains internal heat sources through mechanical friction. These natural heating systems operate with such consistency that they can sustain subsurface liquid reservoirs indefinitely, creating stable aquatic environments protected from surface temperature variations. Some planetary atmospheres develop such perfect chemical stratification that different molecular species naturally sort themselves by molecular weight and chemical properties. This atmospheric layering creates distinct zones where specific chemical reactions occur at optimal conditions, resulting in planetary-scale chemistry laboratories that operate for geological ages. The stability of these chemical gradients ensures that atmospheric processes proceed at steady rates without being disrupted by mixing or contamination from adjacent layers. The way certain binary planet systems orbit their common center of gravity creates gravitational environments where both worlds experience identical tidal cycles that remain synchronized across billions of years. These gravitational twins maintain perfect orbital harmony through mathematical relationships that prevent destabilizing resonances while maximizing tidal heating efficiency. The resulting tidal patterns create rhythmic geological activity that follows predictable cycles based on the orbital period of the binary system. Many solar systems contain debris clouds that have achieved such stable configurations that they serve as natural archives preserving samples of primordial solar system materials. These cosmic museums consist of particles that have remained essentially unchanged since the early stages of planetary formation, maintaining pristine compositions that record conditions during solar system birth. The gravitational stability of these debris clouds ensures that ancient materials remain accessible for billions of years without being contaminated by later evolutionary processes. The electromagnetic interactions between planetary ionospheres and solar wind create natural radio transmission systems that can carry signals across interplanetary distances with remarkable efficiency. When charged particles in planetary upper atmospheres interact with stellar magnetic fields, they generate electromagnetic waves that propagate through space along predictable paths. These natural communication networks demonstrate how electromagnetic phenomena can create organized signal transmission systems without technological intervention. Some worlds develop such perfectly tuned orbital eccentricities that their distance variations from their parent stars create gentle seasonal cycles that enhance rather than disrupt atmospheric stability. These mildly elliptical orbits produce temperature variations that drive atmospheric circulation without creating extreme climate swings. The mathematical precision of these orbital parameters ensures that seasonal changes remain within optimal ranges for maintaining liquid water and stable weather patterns throughout planetary years. The way stellar radiation pressure sorts interplanetary dust particles creates natural materials, science laboratories where cosmic grains organize themselves according to size, density, and optical properties. This cosmic particle sorting operates continuously, creating regions where specific types of dust concentrate based on their response to radiation pressure and electromagnetic forces. The resulting dust distributions reveal fundamental relationships between material properties and electromagnetic interactions on cosmic scales. Many planetary magnetic field configurations create natural particle accelerators that operate through magnetic reconnection events occurring in magnetospheric boundaries. These acceleration regions generate high-energy particle streams that follow magnetic field lines with mathematical precision, creating structured radiation environments that remain stable for millions of years. The particle acceleration process operates automatically whenever solar wind conditions meet planetary magnetic fields at optimal angles and velocities. The thermal conductivity properties of certain planetary crusts create natural heat distribution networks that maintain surface temperatures within narrow ranges despite significant variations in internal heat generation. These geological thermal regulation systems operate through convection and conduction processes that automatically adjust heat flow rates based on temperature gradients. The resulting thermal stability ensures that surface conditions remain suitable for complex geological and potentially biological processes across geological time spans. Some solar systems achieve such perfect mass distribution among their planetary components that gravitational perturbations from external sources are naturally dampened through collective planetary responses. When nearby stars or interstellar objects approach these systems, the combined gravitational influence of multiple planets creates stabilizing effects that prevent orbital disruption. These natural gravitational shock absorbers demonstrate how multi-body gravitational systems can achieve enhanced stability through cooperative interactions. The way atmospheric water cycles operate on certain worlds creates precipitation patterns that maintain optimal surface moisture levels for billions of years. These hydrological systems achieve perfect balance between evaporation, condensation, and precipitation, ensuring that water distribution remains stable despite changes in atmospheric circulation or surface geography. The mathematical precision of these water cycles creates environments where surface chemistry can proceed under consistently optimal hydration conditions. Many worlds develop rotational stability so precise that their axial orientations remain constant relative to their orbital planes for geological ages. This rotational stability prevents climate disruption that might result from chaotic axial precession, ensuring that seasonal patterns remain predictable and moderate. The gyroscopic effects that maintain this stability operate through gravitational interactions with moons, binary companions, or the galactic tidal field, creating natural stabilization systems that persist across cosmic time. The electromagnetic shielding provided by planetary magnetic fields creates protected zones where delicate atmospheric chemistry can proceed without disruption from cosmic radiation or solar particle bombardment. These natural radiation shields operate continuously and automatically, deflecting harmful charged particles while allowing beneficial solar radiation to reach planetary surfaces. The efficiency of these magnetic protection systems ensures that atmospheric compositions remain stable despite variations in cosmic ray intensity or solar activity. Some planetary ring systems develop such sophisticated internal organization that particles automatically sort themselves into discrete bands based on orbital resonances with multiple shepherd moons. These natural particle sorting systems create ring structures with sharp boundaries and distinct compositional differences between adjacent bands. The self-organizing properties of these ring systems demonstrate how gravitational forces can create and maintain complex organizational structures without external control mechanisms. The way certain atmospheric circulation patterns interact with planetary topography creates natural wind tunnel effects that enhance atmospheric mixing efficiency across global scales. These enhanced circulation systems ensure that atmospheric gases remain well mixed despite the presence of mountain ranges, ocean basins, or other topographical barriers. The resulting atmospheric homogeneity creates stable chemical environments where atmospheric processes proceed at optimal rates across entire planetary surfaces. Many solar systems contain gravitational configurations that create natural asteroid deflection systems, protecting inner planets from potentially hazardous impact events. These gravitational shield systems operate through precisely positioned massive planets that capture or redirect incoming debris before it can reach smaller, potentially habitable worlds. The mathematical precision of these protective arrangements demonstrates how gravitational forces can create natural planetary defense mechanisms that operate automatically across geological time. The thermal coupling between planetary cores and mantle systems creates convection patterns that maintain optimal heat flow rates for billions of years. These internal heat engines operate through temperature-driven circulation that automatically adjusts to maintain thermal equilibrium between heat generation and heat loss. The stability of these thermal convection systems ensures that planetary magnetic field generation and geological activity proceed at steady rates without dramatic fluctuations that might destabilize surface conditions. Some worlds achieve such perfect atmospheric optical properties that they create natural greenhouse effects, operating within precisely controlled temperature ranges. These optical greenhouse systems maintain surface temperatures through selective absorption and emission of specific wavelengths of electromagnetic radiation. The spectral precision of these atmospheric optical filters ensures that greenhouse warming remains within optimal ranges, despite variations in stellar luminosity or atmospheric composition. The way planetary satellite systems evolve through tidal interactions creates orbital configurations that maximize gravitational stability while minimizing destructive tidal heating. These evolutionary processes naturally guide satellite orbits toward resonant configurations that balance tidal energy dissipation with orbital stability requirements. The resulting satellite arrangements demonstrate how gravitational evolution tends towards stable, harmonious orbital relationships that can persist for billions of years. Many solar systems develop such efficient cosmic ray shielding that their inner regions remain protected from high-energy particle bombardment for geological ages. This cosmic radiation protection arises from stellar magnetic field interactions with galactic magnetic fields, creating protective bubble regions around entire solar systems. The effectiveness of these natural radiation shields ensures that planetary atmospheres and surface chemistry can evolve without disruption from energetic cosmic particle interactions. The precision with which certain planetary atmospheric compositions maintain chemical equilibrium demonstrates nature's ability to create self-regulating systems that operate without external control. These atmospheric homeostasis mechanisms automatically adjust gas concentrations to maintain optimal conditions for surface processes, responding to perturbations by initiating corrective chemical reactions. The sophistication of these natural regulatory systems rivals the most advanced technological control systems while operating through purely physical and chemical processes. Some planetary magnetic field configurations create natural plasma confinement systems that trap and organize charged particles in stable, long-lasting structures. These natural plasma bottles operate through magnetic field geometries that prevent particle escape while maintaining organized particle distributions. The resulting plasma environments demonstrate how magnetic forces can create persistent, structured, charged particle populations that remain stable for millions of years without external energy input. The way stellar radiation interacts with planetary atmospheric constituents creates natural photochemical laboratories where complex molecular synthesis proceeds at optimal rates for geological ages. These atmospheric chemistry systems operate through precisely tuned photochemical reactions that convert simple atmospheric gases into more complex molecular species. The efficiency of these natural synthesis processes ensures that atmospheric compositions evolve toward increasingly sophisticated chemical complexity over cosmic timescales. As our serene exploration draws us deeper into the mathematical poetry of cosmic mechanics, we encounter evidence that the universe operates according to principles far more elegant and purposeful than random chance might suggest. These stellar neighborhoods reveal themselves as masterworks of natural engineering, where physical laws collaborate to create environments of stunning beauty and enduring stability. The gentle precision underlying these cosmic arrangements offers profound reassurance that order and harmony are fundamental characteristics of the universe itself, operating on scales that transform our understanding of what permanence and beauty truly mean across the infinite expanse of space and time. The crystalline precision of planetary formation reveals nature's most patient artistry at work. When dust grains first begin their slow dance of accretion, they follow gravitational choreography so gentle that collisions occur at speeds measured in centimeters per second, rather than catastrophic impacts. This unhurried process allows particles to stick together, rather than shatter apart, building larger objects, grain by grain, across millions of years. The mathematical elegance of this growth pattern ensures that planetary embryos develop through countless tender encounters, each adding mass without violence or destruction. Some worlds achieve such perfect atmospheric transparency that starlight reaches their surfaces completely unfiltered, creating environments where photochemical processes proceed with maximum efficiency. These crystal-clear atmospheres contain precisely balanced gas mixtures that neither absorb nor scatter incoming radiation, allowing stellar energy to power surface chemistry at optimal rates. The clarity of these atmospheric windows remains constant for billions of years, creating stable photochemical environments where complex molecular reactions can unfold without interference from atmospheric opacity variations. The way certain planetary cores generate magnetic fields through dynamo action creates natural electromagnetic laboratories that operate continuously for geological ages. Deep within these worlds, convecting metallic fluids generate electrical currents that produce stable magnetic field configurations extending far into space. These planetary dynamos operate through thermodynamic processes so efficient that they can maintain strong magnetic fields for billions of years using only the rotational energy and residual heat from planetary formation. The resulting magnetic environments provide natural laboratories where electromagnetic phenomena can be studied across cosmic timescales. Many solar systems contain worlds where surface gravity creates such perfect conditions that atmospheric retention becomes essentially permanent. These gravitational sweet spots allow planets to maintain their gaseous envelopes indefinitely, preventing atmospheric escape while avoiding compression effects that might alter chemical compositions. The precision of these gravitational parameters ensures that atmospheric masses remain stable across geological time, creating environments where atmospheric evolution proceeds through chemical rather than physical processes. The thermal regulation systems operating within certain planetary mantles create natural heat engines that maintain optimal internal temperatures for billions of years. These geological thermostats operate through convection patterns that automatically adjust heat flow rates based on temperature gradients between planetary cores and surfaces. The resulting thermal stability ensures that magnetic field generation and tectonic activity proceed at steady rates without dramatic fluctuations that might destabilize surface conditions or atmospheric compositions. Some atmospheric circulation systems develop such sophisticated organization that they create natural climate control mechanisms operating across entire planetary hemispheres. These global circulation cells establish persistent pressure patterns that maintain stable weather systems for geological ages. The mathematical precision of these circulation patterns ensures that temperature and moisture distribution remain optimal for surface processes, creating environments where climate stability persists despite minor variations in stellar output or atmospheric composition. The way planetary ring particles organize themselves through electromagnetic interactions creates natural examples of collective behavior operating on cosmic scales. When charged dust grains interact with planetary magnetic fields, they develop coordinated motion patterns that maintain ring structure and prevent gravitational collapse. These electromagnetic organizational effects demonstrate how charged particle systems naturally evolve towards stable, aesthetically pleasing configurations that persist across millions of orbital periods. Many worlds develop such perfectly balanced chemical cycles that atmospheric compositions remain essentially constant for billions of years. These natural chemical equilibrium systems operate through feedback mechanisms that automatically adjust reaction rates to maintain optimal gas concentrations. The sophistication of these chemical regulation systems ensures that atmospheric chemistry proceeds at steady rates without being disrupted by accumulation of reaction products or depletion of essential reactants. The gravitational interactions between multiple planetary moons create tidal patterns of such mathematical precision that they generate natural timing mechanisms operating across geological timescales. When satellites achieve resonant orbital relationships, their combined gravitational influence produces tidal cycles that repeat with clockwork accuracy for millions of years. These celestial metronomes demonstrate how gravitational forces naturally create precise timing systems that can serve as cosmic calendars, recording the passage of astronomical time. Some solar systems achieve such perfect debris clearing that their inner regions remain essentially free of impact hazards for billions of years. This cosmic housekeeping occurs through gravitational interactions with massive outer planets that capture or deflect potentially dangerous objects before they can threaten inner worlds. The efficiency of these natural debris removal systems ensures that delicate atmospheric and surface processes can proceed without disruption from catastrophic impact events. The way stellar radiation pressure interacts with planetary atmospheric constituents creates natural particle accelerators that operate through photochemical processes rather than electromagnetic fields. When atmospheric molecules absorb stellar radiation, they gain kinetic energy that drives chemical reactions and atmospheric circulation at precisely controlled rates. These photochemical acceleration mechanisms demonstrate how stellar energy can power atmospheric dynamics through purely optical rather than gravitational or magnetic processes. Many planetary magnetic field configurations create natural plasma confinement systems that maintain organized charged particle populations for millions of years. These magnetic bottles operate through field geometries that prevent particle escape while maintaining optimal particle densities for electromagnetic interactions. The resulting plasma environments demonstrate how magnetic forces can create persistent, structured electromagnetic phenomena that remain stable across geological time without external energy input or control mechanisms. The thermal coupling between planetary atmospheres and surfaces creates natural heat distribution networks that maintain optimal temperature gradients for atmospheric circulation. These thermal coupling systems operate through convection and radiation processes that automatically adjust heat transfer rates based on temperature differences between surface and atmospheric layers. The resulting thermal regulation ensures that atmospheric circulation proceeds at optimal rates without being disrupted by excessive heating or cooling events. Some worlds develop such perfectly tuned orbital parameters that their seasonal cycles create optimal conditions for atmospheric chemical processes throughout planetary years. These orbital configurations produce temperature and radiation variations that enhance rather than disrupt atmospheric chemistry, creating environments where chemical reaction rates follow optimal patterns synchronized with planetary seasons. The mathematical precision of these orbital relationships ensures that seasonal variations remain within ranges that maximize atmospheric chemical efficiency. The way certain planetary satellite systems evolve through gravitational interactions creates orbital configurations that maximize tidal heating efficiency while maintaining long-term stability. These evolutionary processes guide satellite orbits toward resonant relationships that balance energy dissipation with orbital preservation requirements. The resulting satellite arrangements demonstrate how gravitational evolution naturally tends toward configurations that optimize tidal energy production while preventing orbital decay or satellite collision events. Many solar systems contain gravitational environments where small objects can remain in stable orbits for billions of years without requiring orbital maintenance or correction. These natural orbital parking zones arise from gravitational balance points where multiple massive bodies create regions of enhanced stability for smaller objects. The mathematical elegance of these stable orbital regions demonstrates how multi-body gravitational systems naturally create safe harbors where delicate objects can persist across cosmic time. The electromagnetic shielding provided by certain planetary magnetic field configurations creates protected zones where atmospheric chemistry can proceed without interference from cosmic radiation or solar particle bombardment. These natural radiation shields operate automatically and continuously, deflecting harmful charged particles while allowing beneficial electromagnetic radiation to reach atmospheric reaction zones. The effectiveness of these magnetic protection systems ensures that atmospheric chemical processes remain stable despite variations in cosmic radiation intensity. Some planetary atmospheric compositions achieve such perfect optical properties that they create natural greenhouse effects operating within precisely controlled temperature ranges for billions of years. These atmospheric greenhouse systems maintain surface temperatures through selective absorption and emission of electromagnetic radiation at specific wavelengths. The spectral precision of these natural optical filters ensures that greenhouse warming remains within optimal ranges despite variations in stellar luminosity or atmospheric chemical composition. The way planetary core convection patterns interact with rotational dynamics creates natural electromagnetic generators that operate with remarkable efficiency and stability. These planetary dynamos convert thermal and rotational energy into magnetic field energy through magneto-hydrodynamic processes that maintain optimal operating conditions automatically. The resulting magnetic field generation demonstrates how planetary interiors naturally evolve toward configurations that maximize electromagnetic field production while maintaining thermal and mechanical stability. Many worlds develop such sophisticated atmospheric stratification that different chemical processes occur at their optimal altitudes and pressure conditions simultaneously. These natural atmospheric chemistry laboratories operate through density gradients that automatically sort chemical reactions according to their pressure and temperature requirements. The resulting atmospheric organization creates environments where multiple chemical processes can proceed simultaneously without interference or competition for optimal reaction conditions. The gravitational resonances between planetary ring particles and shepherd moons create natural organizational systems that maintain ring structure through gentle gravitational guidance rather than disruptive collisions. These gravitational shepherding mechanisms operate through resonant relationships that provide just enough gravitational nudging to keep ring particles properly distributed without causing destructive encounters. The precision of these gravitational organizational systems demonstrates how celestial mechanics naturally creates and maintains complex structural arrangements. Some solar systems contain worlds where atmospheric circulation patterns create natural acoustic resonance chambers that can amplify and transmit sound waves across continental distances. These atmospheric acoustic systems arise when atmospheric density gradients and circulation patterns combine to create optimal conditions for sound wave propagation. The resulting acoustic environments demonstrate how atmospheric physics can create natural sound transmission systems that operate through purely mechanical rather than electromagnetic wave propagation. The way certain planetary thermal gradients interact with atmospheric composition creates natural convection systems that maintain optimal atmospheric mixing rates for geological ages. These atmospheric circulation engines operate through temperature-driven convection that automatically adjusts circulation intensity based on thermal conditions. The resulting atmospheric mixing ensures that atmospheric gases remain optimally distributed, despite the presence of topographical barriers or local heating variations that might otherwise create atmospheric stagnation zones. Many planetary magnetic field interactions with stellar magnetic fields create natural electromagnetic wave generation systems that operate through magnetic reconnection processes occurring at magnetospheric boundaries. These natural electromagnetic generators produce organized wave patterns that propagate through interplanetary space along predictable trajectories. The electromagnetic wave generation process operates automatically whenever stellar and planetary magnetic fields achieve optimal interaction geometries and field strength relationships. The precision with which certain atmospheric chemical cycles maintain molecular equilibrium demonstrates nature's ability to create self-regulating chemical systems that operate without external control or monitoring. These atmospheric homeostasis mechanisms automatically adjust chemical reaction rates to maintain optimal molecular concentrations, responding to perturbations by initiating corrective chemical processes. The sophistication of these natural chemical regulation systems ensures that atmospheric compositions remain stable despite external chemical inputs or atmospheric loss processes. Some worlds achieve such perfect atmospheric pressure regulation that surface conditions remain optimal for liquid phase chemistry across their entire surfaces for billions of years. These natural pressure regulation systems operate through atmospheric mass distribution and circulation patterns that maintain uniform pressure conditions despite topographical variations or atmospheric heating differences. The resulting pressure stability creates environments where surface chemistry can proceed under consistently optimal conditions throughout planetary surfaces. The way planetary tidal heating systems interact with internal thermal sources creates natural geothermal regulation mechanisms that maintain optimal subsurface temperatures for geological processes. These internal heating systems operate through gravitational energy conversion that automatically adjusts heating rates based on orbital dynamics and internal thermal conditions. The resulting thermal regulation ensures that geological activity proceeds at optimal rates without being disrupted by excessive heating or cooling that might destabilize internal planetary structure. Many solar systems develop such efficient cosmic debris filtering that their habitable zones remain essentially free of disruptive impact events for billions of years. These natural debris management systems operate through gravitational interactions with massive outer planets that capture or deflect potentially hazardous objects before they can reach inner planetary regions. The effectiveness of these natural protection mechanisms ensures that delicate surface and atmospheric processes can evolve without interruption from catastrophic impact events. The electromagnetic coupling between planetary ionospheres and solar wind creates natural plasma physics laboratories where charged particle interactions can be studied across interplanetary scales. These natural plasma environments demonstrate how electromagnetic forces organize charged particles into structured configurations that persist for extended periods. The stability of these plasma structures provides natural examples of electromagnetic confinement and organization operating through purely physical rather than technological processes. Some planetary atmospheric optical properties create natural spectroscopic laboratories where molecular interactions with electromagnetic radiation can be observed across geological timescales. These atmospheric optical systems operate through molecular absorption and emission processes that reveal fundamental relationships between matter and electromagnetic radiation. The consistency of these optical interactions ensures that atmospheric spectroscopic properties remain stable, providing natural standards for understanding electromagnetic matter interactions. The way certain planetary rotation rates interact with atmospheric circulation creates natural fluid dynamics laboratories where atmospheric flow patterns can be studied under optimal conditions for millions of years. These atmospheric circulation systems demonstrate how rotation and thermal gradients naturally organize atmospheric motion into stable, predictable patterns. The mathematical precision of these circulation relationships provides natural examples of fluid mechanics operating under idealized conditions across cosmic timescales. Many worlds develop such perfectly balanced atmospheric chemistry that they maintain optimal conditions for complex molecular synthesis throughout their atmospheric columns for geological ages. These natural atmospheric chemistry systems operate through photochemical and thermochemical processes that automatically maintain optimal reactant concentrations and reaction conditions. The efficiency of these atmospheric synthesis systems demonstrates how natural chemical processes can achieve sophisticated molecular production without external control or energy input beyond stellar radiation. The gravitational stability achieved by certain multiplanetary systems creates natural examples of celestial mechanics operating at maximum efficiency for billions of years. These gravitationally stable configurations demonstrate how multiple massive bodies naturally evolve toward orbital relationships that minimize perturbations while maximizing long-term stability. The mathematical elegance of these stable orbital arrangements provides natural demonstrations of how gravitational forces create persistent, harmonious relationships between massive objects across cosmic time. The way stellar radiation interacts with planetary atmospheric molecules creates natural photochemistry laboratories where light-driven chemical reactions proceed under optimal conditions for geological time periods. These photochemical systems operate through precisely tuned molecular interactions that convert stellar radiation into chemical energy at maximum efficiency. The consistency of these photochemical processes ensures that atmospheric chemistry proceeds at steady rates, creating stable chemical environments that persist across billions of years. Some solar systems achieve such perfect electromagnetic balance that their charged particle environments remain stable despite constant influx of cosmic radiation and solar wind particles. These electromagnetic equilibrium systems operate through magnetic field interactions that automatically adjust particle confinement and acceleration to maintain optimal charged particle populations. The resulting electromagnetic stability creates natural plasma physics environments that persist across geological time without requiring external energy input or control mechanisms. The thermal properties of certain planetary materials create natural temperature regulation systems that maintain optimal surface conditions through automatic thermal adjustment mechanisms. These natural thermostats operate through material properties that automatically adjust thermal conductivity and heat capacity based on temperature conditions. The resulting thermal regulation ensures that surface temperatures remain within optimal ranges for chemical and potentially biological processes, despite variations in stellar heating or internal thermal generation. As we drift through these mathematical symphonies of cosmic harmony, we discover that the universe reveals itself as an infinite composer, orchestrating arrangements of matter and energy that persist across timescales beyond human comprehension. Each solar system becomes a movement in this vast celestial symphony, contributing its own voice to a cosmic composition that speaks of order emerging from apparent chaos, beauty arising from physical law, and peace flowing from the fundamental structures that govern reality itself across all scales of space and time. The magnetic field interactions between certain planetary cores and their surrounding space environments create some of the most enduring protective systems in the cosmos. These invisible shields operate through dynamo processes deep within planetary interiors, where convecting metallic fluids generate electrical currents that produce stable magnetic configurations. The resulting magnetospheres extend thousands of kilometers into space, deflecting harmful cosmic radiation and charged particles that might otherwise strip away precious atmospheres. These natural defense systems require no maintenance or external power sources, operating continuously for billions of years, using only the thermal energy and rotational momentum left over from planetary formation. Within the serene architecture of many solar systems, we find worlds where atmospheric pressure gradients create natural elevator systems for molecular transport. These pressure-driven circulation patterns lift gases from surface levels to high altitudes through gentle convection processes that operate like cosmic escalators. The mathematical precision of these atmospheric circulation systems ensures that molecules are distributed optimally throughout atmospheric columns, creating environments where chemical processes can occur at their ideal pressure and temperature conditions. These natural atmospheric elevators operate continuously, maintaining perfect molecular distribution without the turbulence or disruption that might interfere with delicate chemical equilibria. The way certain planetary satellites maintain orbital relationships creates gravitational environments where tidal forces produce gentle, rhythmic heating that persists for geological ages. When multiple moons achieve precise resonant configurations, their combined gravitational influence generates internal friction through flexing and stretching that maintains subsurface temperatures well above freezing. These natural heating systems operate with such consistency that they can sustain liquid water reservoirs beneath icy crusts for billions of years, creating stable aquatic environments completely protected from surface temperature variations and cosmic radiation exposure. Some solar systems contain debris fields that have achieved such perfect gravitational organization that particles follow mathematical spirals extending across millions of kilometers of space. These cosmic whirlpools demonstrate how gravitational forces naturally organize matter into aesthetically beautiful patterns that persist unchanged for millions of years. Each particle within these spiral structures follows a precisely calculated trajectory that prevents collisions while maintaining the overall geometric pattern. The mathematical elegance of these arrangements reveals how physical laws create art on scales far grander than any human creation. The thermal properties of certain planetary mantles create natural geological clocks that operate through radioactive decay processes occurring at perfectly predictable rates. Deep within these worlds, unstable atomic nuclei release energy through nuclear transformations that follow statistical patterns so reliable they can serve as cosmic timekeepers. The heat generated by these decay processes flows outward through planetary interiors at steady rates, maintaining internal temperatures that drive geological activity with clockwork precision. These natural atomic clocks have been ticking steadily since planetary formation, providing consistent energy sources that will continue operating for billions of years. Many worlds develop atmospheric compositions so precisely balanced that they create natural chemical laboratories where molecular synthesis proceeds at optimal rates throughout planetary atmospheres. These atmospheric chemistry systems maintain perfect concentrations of reactant molecules through feedback mechanisms that automatically adjust chemical reaction rates based on molecular abundance. The resulting chemical equilibria persist for geological ages, creating environments where atmospheric chemistry proceeds like a vast planetary-scale synthesis facility operating without external control or monitoring. The way stellar radiation interacts with certain atmospheric molecules creates natural optical computers that process information through photochemical reactions occurring across entire atmospheric columns. These molecular information processing systems operate through light-driven chemical changes that store and manipulate data in molecular configurations. The computational processes occur automatically whenever stellar radiation reaches atmospheric molecules, creating natural data processing systems that operate continuously during daylight hours. These atmospheric computers demonstrate how photochemistry can create information processing capabilities using purely natural molecular interactions. Some planetary ring systems develop such sophisticated internal dynamics that individual particles communicate their positions to neighboring particles through gravitational interactions, creating collective behaviors that maintain ring stability across millions of years. These particle communication networks operate through tiny gravitational influences that allow each ring particle to sense the positions and velocities of its neighbors. The resulting collective behavior creates self-organizing systems where billions of particles coordinate their motions to maintain optimal ring structure without any central control mechanism. The gravitational interactions between binary planet systems create tidal environments where surface features rise and fall in mathematical patterns that repeat with extraordinary precision across geological time. These gravitational sculptures operate through tidal forces that reshape planetary surfaces according to the orbital dynamics of binary companions. The resulting surface topography changes follow predictable mathematical relationships based on orbital periods and gravitational field strengths, creating landscapes that breathe in harmony with celestial mechanics. Many solar systems achieve such perfect mass distribution among their components that gravitational perturbations from passing stars are automatically dampened through collective planetary responses. When external gravitational influences threaten orbital stability, the combined gravitational fields of multiple planets create compensating forces that restore equilibrium. These natural gravitational shock absorber systems demonstrate how multi-body gravitational configurations naturally evolve toward enhanced stability and resistance to external disruption. The way atmospheric water cycles operate on certain worlds creates precipitation patterns that deliver precisely the right amounts of moisture to different geographical regions for billions of years. These natural irrigation systems operate through atmospheric circulation patterns that transport water vapor from evaporation zones to condensation regions with mathematical precision. The resulting precipitation distribution ensures that surface chemistry proceeds under optimal hydration conditions across entire planetary surfaces, creating environments where chemical weathering and geological processes operate at ideal rates. Some worlds maintain such perfect atmospheric optical properties that they create natural greenhouse effects operating within temperature ranges so narrow that surface conditions remain essentially constant for geological ages. These atmospheric greenhouse systems regulate planetary temperatures through selective absorption and emission of electromagnetic radiation at precisely tuned wavelengths. The spectral characteristics of these atmospheric optical filters ensure that greenhouse warming remains within optimal ranges despite gradual changes in stellar luminosity that occur as parent stars age. The electromagnetic coupling between planetary magnetic fields and solar wind creates natural particle accelerators that generate high-energy charged particle populations through magnetic reconnection events occurring at magnetospheric boundaries. These natural accelerators operate whenever stellar magnetic fields interact with planetary magnetospheres under optimal geometric conditions. The resulting particle acceleration processes create structured radiation environments that remain stable for extended periods, demonstrating how electromagnetic forces can generate and maintain high-energy particle populations without technological intervention. Many planetary core convection systems develop such efficient heat transfer mechanisms that they maintain optimal internal temperatures for magnetic field generation across billions of years. These natural thermal engines operate through convection patterns that automatically adjust heat flow rates based on temperature gradients between core and mantle regions. The resulting thermal regulation ensures that planetary dynamos operate at peak efficiency, generating strong magnetic fields that provide electromagnetic protection for atmospheric and surface processes. The way certain atmospheric circulation patterns interact with planetary topography creates natural wind tunnel effects that enhance atmospheric mixing efficiency across continental scales. These enhanced circulation systems ensure that atmospheric gases remain optimally distributed, despite geographical barriers that might otherwise create atmospheric stagnation zones. The resulting atmospheric homogeneity creates stable chemical environments where atmospheric processes proceed at uniform rates across entire planetary hemispheres. Some solar systems contain gravitational configurations that create natural asteroid guidance systems, steering potentially hazardous objects into safe orbits before they can threaten inner planetary regions. These gravitational traffic control systems operate through precisely positioned massive planets that use their gravitational influence to redirect incoming debris along safe trajectories. The mathematical precision of these gravitational guidance systems ensures that potentially dangerous objects are automatically diverted away from vulnerable inner worlds. The thermal coupling between planetary surfaces and atmospheric systems creates natural climate control mechanisms that maintain optimal temperature distributions across planetary surfaces for geological time periods. These thermal coupling systems operate through heat transfer processes that automatically balance temperature differences between surface and atmospheric regions. The resulting thermal equilibrium ensures that climate conditions remain stable despite minor variations in stellar heating or internal thermal generation that might otherwise disrupt atmospheric circulation patterns. Many worlds develop such perfectly synchronized day-night cycles that their atmospheric chemistry follows optimal reaction schedules based on photochemical and thermal processes occurring at precisely timed intervals. These natural chemical clocks operate through circadian-like rhythms, where light-dependent and temperature-dependent reactions proceed in coordinated sequences. The resulting chemical cycles ensure that atmospheric molecular synthesis occurs at maximum efficiency, creating environments where atmospheric chemistry proceeds like a vast planetary-scale chemical factory operating on astronomical time schedules. The way planetary magnetic field configurations interact with cosmic ray particles creates natural charged particle sorting systems that organize cosmic radiation according to energy and particle type. These electromagnetic sorting mechanisms operate through magnetic field geometries that deflect different types of charged particles along specific trajectories based on their mass and energy characteristics. The resulting particle organization creates structured radiation environments, where different types of cosmic radiation follow predictable paths through planetary magnetospheres. Some atmospheric systems develop such sophisticated pressure regulation that they maintain optimal conditions for gas phase chemical reactions throughout atmospheric columns for billions of years. These natural pressure control systems operate through atmospheric mass distribution and circulation patterns that automatically adjust pressure gradients based on atmospheric density variations. The resulting pressure stability creates environments where atmospheric chemistry proceeds under consistently optimal conditions regardless of altitude or geographical location. The gravitational resonances between multiple planetary rings and their shepherd moons create natural organizational systems that maintain ring particle distributions through gentle gravitational nudging rather than disruptive collisions. These gravitational shepherding mechanisms operate through resonant relationships that provide precisely calibrated gravitational influences to keep ring particles properly spaced. The mathematical precision of these gravitational organizational systems ensures that ring structures remain stable and aesthetically beautiful across millions of orbital periods. Many solar systems achieve such efficient cosmic debris management that their inner regions remain essentially impact-free for billions of years through natural gravitational cleaning systems. These cosmic housekeeping mechanisms operate through gravitational interactions with massive outer planets that systematically capture or deflect potentially hazardous objects before they can reach inner planetary zones. The effectiveness of these natural debris removal systems creates safe environments where delicate atmospheric and surface processes can evolve without disruption from catastrophic impact events. The way stellar magnetic fields interact with planetary magnetic fields creates natural electromagnetic wave generation systems that produce organized radio signals propagating through interplanetary space. These natural radio transmitters operate through magnetic field interactions that generate electromagnetic waves when stellar and planetary magnetic fields achieve optimal coupling configurations. The resulting electromagnetic signals demonstrate how magnetic field interactions can create natural communication systems operating across interplanetary distances without technological intervention. Some worlds develop such perfectly balanced geological activity that their surface renewal processes operate at optimal rates for maintaining planetary habitability across geological time. These natural geological recycling systems operate through tectonic and volcanic processes that automatically adjust activity levels based on internal thermal conditions and surface chemistry requirements. The resulting geological balance ensures that planetary surfaces remain chemically active without experiencing destructive geological catastrophes that might sterilize surface environments. The thermal properties of certain planetary atmospheric compositions create natural temperature buffering systems that automatically adjust atmospheric heating and cooling rates to maintain stable surface temperatures. These atmospheric thermostats operate through molecular properties that change thermal absorption and emission characteristics based on atmospheric temperature conditions. The resulting thermal regulation ensures that surface temperatures remain within optimal ranges for liquid phase chemistry, despite variations in stellar radiation or atmospheric composition. Many planetary satellite systems evolve through gravitational interactions toward orbital configurations that maximize tidal heating efficiency while maintaining perfect long-term orbital stability. These evolutionary processes demonstrate how gravitational forces naturally guide satellite systems toward optimal energy dissipation rates that can sustain internal heating indefinitely. The resulting orbital arrangements create natural heating systems that operate with remarkable efficiency and longevity, providing steady energy sources for billions of years. The way atmospheric molecular interactions create natural optical phenomena demonstrates how chemical processes can generate beautiful visual displays that persist across geological time. When specific atmospheric molecules interact with stellar radiation, they produce optical effects such as enhanced scattering, selective absorption, or molecular emission that create distinctive atmospheric colors and lighting effects. These natural light shows operate continuously during appropriate illumination conditions, creating atmospheric displays that remain consistent for millions of years. Some solar systems contain worlds where atmospheric acoustic properties create natural sound transmission systems that can carry acoustic waves across continental distances with minimal distortion. These atmospheric acoustic environments arise when atmospheric density gradients and circulation patterns combine to create optimal conditions for sound wave propagation. The resulting acoustic transmission systems demonstrate how atmospheric physics can create natural communication networks, operating through mechanical wave propagation rather than electromagnetic signals. The electromagnetic shielding provided by certain stellar magnetic field configurations creates protected zones around entire solar systems, where cosmic radiation intensities remain reduced for billions of years. These natural radiation shields operate through stellar magnetic fields that deflect galactic cosmic rays and other high-energy particles before they can reach planetary environments. The effectiveness of these stellar electromagnetic protection systems ensures that planetary atmospheres and surface chemistry can evolve in radiation environments that remain stable despite galactic cosmic ray variations. Many worlds achieve such perfect atmospheric chemical equilibrium that reactive gas concentrations remain stable for geological ages through natural chemical regulation systems. These atmospheric homeostasis mechanisms automatically adjust chemical reaction rates to maintain optimal molecular concentrations, despite external chemical inputs or atmospheric loss processes. The sophistication of these natural chemical control systems ensures that atmospheric compositions remain optimized for complex chemistry throughout planetary lifetimes. The way certain planetary internal heating systems interact with surface thermal processes creates natural geothermal regulation that maintains optimal subsurface temperatures for geological and potentially biological processes. These internal thermal regulation systems operate through heat generation and transport mechanisms that automatically adjust thermal output based on internal temperature conditions and surface thermal requirements. The resulting thermal stability creates subsurface environments where temperature-dependent processes can proceed at optimal rates for billions of years. The gravitational interactions between solar system components create natural timing mechanisms where orbital periods and rotational cycles align in mathematical relationships that persist across cosmic time. These celestial chronometers operate through gravitational resonances that lock astronomical motions into precise temporal relationships. The mathematical beauty of these natural timing systems demonstrates how gravitational forces create cosmic calendars and clocks that measure time with extraordinary precision across geological ages. Some atmospheric circulation systems develop such remarkable organization that they create natural meteorological laboratories where weather patterns can be studied under idealized conditions for millions of years. These atmospheric research environments arise when circulation patterns achieve stable configurations that maintain consistent weather dynamics across geological time. The resulting meteorological systems provide natural examples of atmospheric fluid dynamics operating under optimal conditions without external perturbations that might disrupt atmospheric flow patterns. The way planetary magnetic dynamos interact with rotational dynamics creates natural electromagnetic generators that convert rotational energy into magnetic field energy with remarkable efficiency and stability. These planetary electromagnetic power systems operate through magnetohydrodynamic processes that automatically optimize energy conversion rates based on rotational velocity and internal thermal conditions. The resulting magnetic field generation demonstrates how planetary interiors naturally evolve toward configurations that maximize electromagnetic energy production while maintaining mechanical and thermal stability. As our peaceful journey through these cosmic sanctuaries continues, we find ourselves surrounded by evidence of the universe's infinite capacity for creating environments of profound stability and mathematical beauty. Each solar system reveals itself as a masterwork of natural engineering, where physical laws collaborate across billions of years to maintain conditions of remarkable harmony and endurance. The gentle precision underlying these stellar neighborhoods demonstrates that the cosmos operates according to principles far more elegant and purposeful than mere chance, creating oases of order and tranquility that persist across timescales that dwarf all human experience and transform our understanding of what permanence and beauty truly mean in the infinite theatre of space and time. The crystalline architecture of certain planetary ring systems reveals nature's most delicate engineering achievements, where billions of ice particles arrange themselves into structures so thin they would be nearly invisible from the side, yet so perfectly organized they can persist for millions of years. These gossamer bands of frozen material orbit with such precision that each particle knows its exact place in the cosmic dance, never colliding, never straying from its designated path. The mathematical beauty of these arrangements emerges from simple gravitational relationships, where tiny gravitational nudges from distant moons keep particles aligned in bands thinner than a city block, but spanning distances greater than the width of continents. Some worlds achieve such perfect atmospheric stratification that their skies become natural libraries with different chemical stories written at each altitude. The lowest atmospheric layers might contain water vapor and simple organic molecules, while higher regions host more exotic chemistry involving rare gases and complex molecular structures. These atmospheric archives preserve information about planetary history, stellar evolution, and cosmic chemistry in vertical layers that remain undisturbed for geological ages. Each altitude represents a different chapter in the planet's atmospheric biography, creating three-dimensional chemical landscapes that stretch from surface to space. The way certain binary star systems nurture planetary formation creates environments where worlds experience double the stellar protection and enhanced gravitational stability. These twin suns work together like cosmic guardians, their combined gravitational influence creating safer zones where planets can form and evolve without the disruption that might occur around solitary stars. The dual stellar radiation also provides backup energy sources, ensuring that if one star experiences temporary dimming or flaring, the companion star continues to provide steady illumination. This stellar redundancy creates some of the most stable planetary environments in the galaxy. Many solar systems contain worlds where surface geology operates like vast, slow-breathing organisms, with continental plates moving in rhythms so gentle they create mountain ranges through processes resembling planetary meditation. These geological breathing patterns operate through convection currents in planetary mantles that rise and fall with the patience of cosmic lungs, reshaping surfaces through uplift and erosion that occurs over millions of years. The resulting topographical changes follow mathematical patterns based on internal heat flow and gravitational dynamics, creating landscapes that evolve like slow-motion sculptures carved by invisible hands. The magnetic field interactions between certain gas giant planets and their numerous moons create electromagnetic environments where charged particles follow helical pathways of extraordinary mathematical elegance. These natural particle highways channel cosmic radiation along spiral trajectories that connect planetary magnetospheres with satellite magnetic fields, creating structured radiation environments that remain stable for millions of years. The resulting electromagnetic architecture demonstrates how magnetic forces naturally organize charged particle populations into aesthetically beautiful and functionally efficient transportation networks spanning hundreds of thousands of kilometers. Some atmospheric systems develop such sophisticated molecular sorting mechanisms that different gas species naturally segregate according to molecular weight and chemical properties, creating atmospheric environments where each chemical species finds its optimal altitude and concentration. These natural atmospheric classification systems operate through diffusion and circulation processes that automatically maintain optimal molecular distributions throughout atmospheric columns. The resulting chemical organization creates environments where atmospheric chemistry proceeds with maximum efficiency, as each molecular species operates within its ideal pressure and temperature range. The way stellar evolution interacts with planetary atmospheric evolution creates natural greenhouse regulation systems that automatically adjust atmospheric compositions to maintain optimal surface temperatures throughout stellar aging cycles. As parent stars gradually brighten over billions of years, planetary atmospheres respond by reducing greenhouse gas concentrations through chemical processes that operate like automatic thermostats. These atmospheric adjustment mechanisms ensure that surface temperatures remain within narrow ranges suitable for liquid water chemistry, despite significant changes in stellar luminosity that occur as stars age. Many worlds develop subsurface ocean systems that maintain perfect thermal stability through tidal heating mechanisms operating with the reliability of cosmic central heating systems. The gravitational flexing caused by orbital motion generates internal friction that produces steady heat flow, maintaining subsurface temperatures well above freezing for billions of years. These hidden thermal environments create some of the most stable aquatic conditions in the universe, protected from surface temperature variations and cosmic radiation by insulating layers of ice or rock that act like planetary blankets. The gravitational resonances between multiple asteroid belts create natural debris management systems that maintain organized distributions of small bodies throughout solar systems for geological ages. These gravitational organizational mechanisms prevent asteroids from accumulating in regions where they might destabilize planetary orbits, instead shepherding them into stable zones where they can persist without causing disruption. The mathematical precision of these natural traffic control systems demonstrates how gravitational interactions automatically organize matter into safe, stable configurations. Some planetary rotation rates achieve such perfect synchronization with their orbital periods that they maintain constant orientations relative to their parent stars, creating worlds where one hemisphere experiences eternal day while the other remains in perpetual night. This tidal locking creates thermal environments of remarkable stability, where temperature patterns remain essentially unchanged for billions of years. The boundary regions between these extreme zones develop moderate climate conditions that persist indefinitely, creating permanent twilight zones where temperatures remain comfortable and atmospheric circulation operates with clockwork precision. The way certain planetary magnetic dynamos interact with core cooling processes creates electromagnetic field generation systems that operate with increasing efficiency as planets age. These natural electromagnetic generators actually improve their performance over time as thermal gradients optimize and convection patterns mature, creating magnetic fields that grow stronger and more stable as planetary systems evolve. The resulting electromagnetic protection increases over geological time, demonstrating how planetary magnetic systems naturally evolve toward enhanced protective capabilities. Many solar systems achieve such perfect orbital spacing that planetary gravitational fields create natural harmonic relationships, where orbital periods relate to each other through exact mathematical ratios. These gravitational harmonies ensure that planetary alignments occur at regular, predictable intervals that follow musical-like patterns spanning thousands of years. The mathematical beauty of these orbital relationships creates cosmic symphonies where planetary positions repeat in complex but perfectly predictable rhythms that demonstrate the underlying mathematical order governing celestial mechanics. The thermal regulation systems operating within certain planetary crusts create natural geological thermostats that maintain optimal internal temperatures for magnetic field generation and geological activity. These internal thermal control mechanisms operate through heat transport processes that automatically adjust thermal flow rates based on internal temperature gradients and surface thermal conditions. The resulting thermal stability ensures that geological processes proceed at steady rates, creating environments where planetary evolution follows predictable patterns across billions of years. Some atmospheric circulation systems develop such remarkable efficiency that they create natural climate control networks spanning entire planetary hemispheres through organized wind patterns that persist for geological ages. These global circulation cells establish pressure gradients that maintain stable weather systems across continental scales, ensuring that temperature and moisture distribution remain optimal for surface chemistry. The mathematical precision of these circulation patterns creates environments where climate stability persists, despite minor variations in stellar output or atmospheric composition that might otherwise disrupt weather systems. The way planetary ring particles interact with electromagnetic fields creates natural particle sorting systems that organize ring material according to size, composition, and electrical properties. These electromagnetic classification mechanisms operate through charged particle interactions that automatically separate different types of ring material into distinct bands with sharp compositional boundaries. The resulting ring organization demonstrates how electromagnetic forces can create and maintain complex structural arrangements without external control or intervention. Many worlds develop such perfectly balanced water cycles that precipitation patterns deliver precisely optimal amounts of moisture to different geographical regions for billions of years. These natural irrigation systems operate through atmospheric circulation patterns that transport water vapor from evaporation zones to condensation regions with mathematical precision based on thermal gradients and pressure differences. The resulting moisture distribution ensures that surface chemistry and geological weathering proceed under ideal hydration conditions across entire planetary surfaces. The electromagnetic shielding provided by certain stellar wind interactions creates natural radiation protection systems that operate across entire solar systems, maintaining reduced cosmic radiation environments for geological ages. These stellar electromagnetic umbrellas deflect galactic cosmic rays and other high-energy particles through magnetic field interactions that create protective zones around planetary systems. The effectiveness of these natural radiation shields ensures that delicate atmospheric and surface processes can proceed without disruption from variable cosmic radiation environments. Some planetary core convection systems achieve such optimal heat transfer efficiency that they maintain perfect thermal equilibrium between heat generation and heat loss for billions of years. These natural thermal engines operate through convection patterns that automatically adjust circulation rates based on thermal conditions, ensuring that internal temperatures remain within optimal ranges for magnetic field generation and geological activity. The resulting thermal stability creates environments where planetary magnetic fields operate at peak efficiency throughout geological time. The way certain atmospheric molecular interactions create optical phenomena demonstrates how chemical processes naturally generate beautiful visual displays that remain consistent for millions of years. When specific atmospheric molecules interact with stellar radiation, they produce distinctive optical effects such as enhanced scattering, selective absorption, or molecular emission that create characteristic atmospheric colors and lighting effects. These natural atmospheric artworks operate continuously during appropriate illumination conditions, creating visual displays that serve as atmospheric signatures persisting across geological ages. Many solar systems contain gravitational configurations that create natural debris deflection systems, protecting inner planets from potentially hazardous impact events through gravitational interactions with massive outer planets. These cosmic protection mechanisms operate through precisely positioned massive worlds that use their gravitational influence to capture or redirect dangerous objects before they can reach vulnerable inner planetary regions. The mathematical precision of these natural planetary defense systems ensures that potentially catastrophic impact events are automatically prevented through gravitational traffic control. The thermal coupling between planetary surfaces and atmospheric systems creates natural temperature regulation mechanisms that maintain optimal climate conditions across planetary surfaces for geological time periods. These thermal coupling systems operate through heat transfer processes that automatically balance temperature differences between surface and atmospheric regions based on thermal conductivity and convection efficiency. The resulting thermal equilibrium ensures that surface temperatures remain stable despite variations in stellar heating or internal thermal generation. Some worlds achieve such perfect atmospheric chemical balance that reactive gas species coexist in stable ratios for billions of years through natural chemical regulation systems that automatically adjust reaction rates to maintain optimal molecular concentrations. These atmospheric homeostasis mechanisms operate through feedback processes that respond to chemical perturbations by initiating corrective reactions that restore chemical equilibrium. The sophistication of these natural chemical control systems ensures that atmospheric compositions remain optimized for complex chemistry throughout planetary lifetimes. The gravitational interactions between planetary satellite systems create tidal environments where surface features undergo rhythmic changes that follow mathematical patterns, repeating with extraordinary precision across geological time. These gravitational sculptures operate through tidal forces that reshape planetary surfaces according to orbital dynamics and gravitational field strengths, creating landscapes that change in harmony with celestial mechanics. The resulting surface topography variations demonstrate how gravitational forces naturally create artistic patterns on planetary scales. Many atmospheric systems develop such sophisticated pressure regulation that they maintain optimal conditions for chemical reactions throughout atmospheric columns, despite altitude-dependent pressure variations. These natural atmospheric pressure control systems operate through circulation patterns and atmospheric mass distribution that automatically adjust pressure gradients based on atmospheric density variations and thermal conditions. The resulting pressure stability creates environments where atmospheric chemistry proceeds under consistently optimal conditions, regardless of altitude or geographical location. The way stellar magnetic fields interact with interplanetary dust creates natural particle acceleration systems that organize cosmic dust populations according to size and electrical properties. These electromagnetic sorting mechanisms operate through magnetic field interactions that accelerate charged dust particles along specific trajectories based on their physical characteristics. The resulting dust organization creates structured interplanetary environments where different types of cosmic dust follow predictable orbital patterns that remain stable for millions of years. Some planetary magnetic field configurations create natural electromagnetic wave generation systems that produce radio signals through magnetic reconnection events occurring when planetary and stellar magnetic fields interact under optimal geometric conditions. These natural radio transmitters operate automatically whenever magnetic field configurations achieve the precise alignments necessary for efficient electromagnetic wave production. The resulting radio signals demonstrate how magnetic field interactions can create natural communication systems operating across interplanetary distances. The thermal properties of certain planetary atmospheric compositions create natural greenhouse effects that operate within precisely controlled temperature ranges, maintaining optimal surface conditions for liquid chemistry across billions of years. These atmospheric greenhouse systems regulate planetary temperatures through selective absorption and emission of electromagnetic radiation at specific wavelengths based on molecular properties. The spectral precision of these natural optical filters ensures that greenhouse warming remains within optimal ranges, despite gradual changes in stellar luminosity. Many worlds develop geological activity patterns that operate like planetary heartbeats, with volcanic and tectonic processes following rhythmic cycles that maintain optimal surface renewal rates for geological ages. These natural geological pacemakers operate through internal thermal cycles and stress accumulation patterns that create periodic geological activity following predictable timing patterns. The resulting geological rhythms ensure that planetary surfaces remain chemically active and geologically dynamic without experiencing destructive catastrophic events. The electromagnetic coupling between planetary ionospheres and cosmic ray particles creates natural charged particle research laboratories where electromagnetic interactions can be studied under controlled conditions for millions of years. These natural plasma physics environments demonstrate how electromagnetic forces organize charged particles into structured configurations that persist across geological time. The stability of these electromagnetic structures provides natural examples of plasma confinement and particle acceleration operating through purely physical processes. Some solar systems achieve such efficient cosmic ray management that their inner regions maintain reduced radiation environments for billions of years through natural electromagnetic shielding systems operating at multiple scales. These radiation protection networks operate through stellar magnetic fields, planetary magnetospheres, and interplanetary magnetic structures that collectively deflect harmful cosmic radiation. The effectiveness of these multi-layered protection systems creates safe environments where delicate chemical and potentially biological processes can proceed without disruption from variable cosmic radiation. The way atmospheric circulation patterns interact with planetary magnetic fields creates natural electromagnetic induction systems that generate electrical currents through atmospheric motion in magnetic field environments. These natural atmospheric generators operate through the motion of ionized atmospheric gases through planetary magnetic fields, creating electrical phenomena that follow predictable patterns based on atmospheric circulation dynamics. The resulting electromagnetic effects demonstrate how atmospheric physics and planetary magnetism naturally create electrical phenomena on planetary scales. Many planetary core thermal regulation systems achieve such perfect efficiency that they maintain optimal operating temperatures for magnetic field generation across billions of years through automatic thermal adjustment mechanisms. These internal thermal control systems operate through convection and heat transport processes that automatically optimize thermal flow rates based on core temperature conditions and magnetic field requirements. The resulting thermal stability ensures that planetary electromagnetic protection systems operate at peak efficiency throughout geological time. The gravitational resonances between multiple ring systems and their associated satellite networks create natural organizational hierarchies that maintain complex structural arrangements through coordinated gravitational interactions spanning millions of kilometers. These multi-component gravitational systems demonstrate how celestial mechanics naturally creates organizational structures where rings, moons, and planets work together to maintain stable, aesthetically beautiful configurations. The mathematical elegance of these gravitational hierarchies reveals the underlying order that emerges from gravitational interactions operating across cosmic scales. As our serene exploration draws us ever deeper into these cosmic gardens of tranquility, we discover that the universe operates as an infinite wellspring of mathematical poetry, where physical laws collaborate across unimaginable spans of time and space to create environments of profound beauty and enduring peace. Each solar system becomes a verse in this cosmic poem, written in the language of gravitational harmony and electromagnetic elegance, speaking to us of order that emerges from apparent complexity and stability that persists across epochs that dwarf all earthly experience, revealing the universe as a realm where patience and precision craft wonders that transform our understanding of what serenity and permanence truly mean in the boundless symphony of existence. The gravitational ballet performed by Trojan asteroids reveals one of nature's most elegant solutions to cosmic cohabitation. These celestial companions share planetary orbits while maintaining perfect distances, trapped in gravitational sweet spots that lead or follow their host planets by exactly 60 degrees. This triangular arrangement, predicted by mathematical theory and confirmed by observation, demonstrates how three-body gravitational systems naturally settle into stable configurations that can persist for billions of years. The asteroids never approach their planetary companions closely enough to cause disruption, instead traveling like cosmic escorts that maintain respectful distances while sharing the same solar highway. The way certain planetary atmospheres achieve perfect optical transparency creates environments where stellar radiation reaches surfaces with maximum efficiency and minimal distortion. These crystal-clear atmospheric windows result from precisely balanced gas mixtures that neither absorb nor scatter incoming light, allowing photochemical processes to operate under ideal conditions. The atmospheric clarity remains constant across geological time, creating stable optical environments where surface chemistry proceeds without interference from atmospheric opacity variations or spectral filtering effects that might alter reaction rates. Many worlds develop internal heat distribution systems that operate like vast geological circulatory networks, transporting thermal energy from radioactive cores to surfaces through convection patterns that remain stable for billions of years. These natural thermal distribution systems ensure that geological activity proceeds at optimal rates across entire planetary surfaces, preventing the formation of geologically dead zones while avoiding excessive heating that might destabilize surface conditions. The thermal circulation patterns establish themselves early in planetary evolution and maintain their efficiency throughout geological time. The electromagnetic interactions between certain stellar winds and planetary magnetic fields create natural plasma laboratories where charged particle physics can be studied under controlled conditions for millions of years. These space-based experimental facilities demonstrate how electromagnetic forces organize charged particles into structured configurations that reveal fundamental properties of plasma behavior. The consistency of these electromagnetic environments ensures that plasma physics phenomena remain observable and predictable across cosmic timescales, providing natural laboratories for understanding charged particle interactions. Some solar systems achieve such perfect debris management that their asteroid belts organize themselves into geometric patterns resembling cosmic jewelry arrangements that persist for geological ages. These naturally occurring ring structures demonstrate how gravitational forces can sort and organize small bodies according to size, composition, and orbital characteristics. The resulting asteroid arrangements create stable configurations where collision rates remain minimal, allowing these cosmic gemstone collections to maintain their beauty and organization across millions of years. The way planetary rotation periods synchronize with orbital dynamics creates natural timing mechanisms that operate with the precision of cosmic chronometers for billions of years. When worlds achieve rotational resonances with their orbital periods, they establish timing relationships that remain stable across geological time, creating natural calendars and clocks that measure astronomical time with mathematical precision. These celestial timepieces demonstrate how rotational and orbital mechanics naturally evolve towards synchronized relationships that enhance gravitational stability. Many atmospheric circulation systems develop such remarkable organization that they create global weather networks where storm systems follow predictable paths and seasonal patterns repeat with clockwork accuracy for geological ages. These atmospheric highway systems transport heat, moisture, and chemical constituents across planetary surfaces through circulation patterns that remain stable despite minor variations in stellar heating or atmospheric composition. The resulting climate stability ensures that weather systems operate like well-organized transportation networks spanning entire worlds. The thermal regulation achieved by certain planetary greenhouse systems creates natural climate control mechanisms that automatically adjust atmospheric compositions to maintain optimal surface temperatures throughout stellar evolution cycles. As parent stars gradually change their energy output over billions of years, these atmospheric thermostats respond by modifying greenhouse gas concentrations through chemical processes that operate without external control. The precision of these atmospheric adjustments ensures that surface temperatures remain within narrow ranges, suitable for complex chemistry despite significant stellar luminosity variations. Some worlds maintain such perfectly stable subsurface ocean systems that these hidden seas persist for billions of years under protective layers of ice or rock, insulated from surface temperature variations and cosmic radiation. The thermal stability of these buried aquatic environments results from tidal heating mechanisms that operate with the reliability of geological furnaces, maintaining liquid water temperatures through gravitational energy conversion. These subsurface oceans represent some of the most stable aquatic conditions imaginable, where chemical processes can proceed undisturbed for cosmic ages. The gravitational focusing effects created by certain massive planets demonstrate how celestial mechanics can concentrate cosmic materials into narrow streams that deliver resources to specific regions with remarkable precision. These natural delivery systems operate through gravitational interactions that focus interplanetary dust, meteoric material, and other cosmic debris into concentrated flows that reach planetary surfaces at predictable rates. The mathematical elegance of these gravitational focusing mechanisms ensures that material delivery occurs in manageable quantities rather than catastrophic bombardments. Many planetary magnetic dynamos achieve such optimal operating efficiency that they actually strengthen over time as thermal gradients mature and convection patterns optimize, creating electromagnetic protection systems that improve with age. These natural electromagnetic generators demonstrate how planetary magnetic systems evolve toward enhanced performance, providing increasingly effective shielding against cosmic radiation as planetary systems mature. The resulting electromagnetic protection creates increasingly safe environments for surface and atmospheric processes. The way certain atmospheric molecular interactions create persistent optical phenomena demonstrates how chemical processes naturally generate beautiful visual displays that remain consistent across geological time. When atmospheric molecules achieve optimal concentrations and distribution patterns, they interact with stellar radiation to produce distinctive optical effects such as enhanced scattering, selective absorption, or molecular emission that create characteristic atmospheric signatures. These natural light shows operate continuously during appropriate illumination conditions, creating atmospheric displays that persist for millions of years. Some solar systems contain worlds where crystalline geological formations create natural prisms that split sunlight into rainbow displays spanning entire continents for geological ages. These planetary light shows occur when specific mineral formations achieve orientations that interact optimally with incoming stellar radiation, creating optical effects that paint landscapes with colored light. The geological stability of these crystal formations ensures that these natural light displays persist unchanged, creating environments where colored illumination becomes a permanent feature of planetary landscapes. The electromagnetic shielding provided by certain stellar magnetic field configurations creates protected zones around entire solar systems where cosmic radiation intensities remain reduced for billions of years. These stellar electromagnetic umbrellas operate through magnetic field interactions that deflect galactic cosmic rays and other high-energy particles before they can reach planetary environments. The effectiveness of these natural radiation protection systems ensures that delicate atmospheric and surface chemistry can proceed in stable radiation environments. Many worlds develop atmospheric stratification so perfect that different chemical processes occur at precisely optimal altitudes throughout atmospheric columns, creating three-dimensional chemistry laboratories that operate for geological ages. These atmospheric chemical factories organize themselves through density gradients and circulation patterns that automatically maintain optimal conditions for specific chemical reactions at their ideal pressure and temperature ranges. The resulting atmospheric organization maximizes chemical efficiency while preventing interference between different chemical processes. The way planetary satellite systems evolve through gravitational interactions creates orbital configurations that maximize energy efficiency while maintaining perfect long-term stability through resonant relationships. These evolutionary processes guide satellite orbits toward mathematical relationships that optimize gravitational interactions while preventing destabilizing encounters. The resulting orbital arrangements demonstrate how gravitational systems naturally evolve toward configurations that balance energy dissipation with orbital preservation requirements. Some atmospheric systems achieve such sophisticated pressure regulation that they maintain uniform atmospheric pressure across entire planetary surfaces, despite significant topographical variations and altitude differences. These natural atmospheric pressure control systems operate through circulation patterns and atmospheric mass distribution that automatically compensate for geographical barriers and elevation changes. The resulting pressure uniformity creates environments where atmospheric chemistry proceeds under consistently optimal conditions, regardless of geographical location. The thermal coupling between certain planetary cores and their surrounding environments creates natural geothermal regulation systems that maintain optimal internal temperatures for geological activity and magnetic field generation. These internal thermal management systems operate through heat transport mechanisms that automatically adjust thermal flow rates based on core temperature conditions and surface thermal requirements. The resulting thermal stability ensures that geological processes and electromagnetic field generation proceed at optimal rates throughout planetary lifetimes. Many solar systems achieve such efficient cosmic debris filtering that their habitable zones remain essentially impact-free for billions of years through natural gravitational protection mechanisms. These cosmic housekeeping systems operate through gravitational interactions with massive outer planets that systematically capture or deflect potentially hazardous objects before they can threaten inner planetary regions. The effectiveness of these natural debris management systems creates safe environments where delicate surface and atmospheric processes can evolve without disruption. The way stellar radiation pressure interacts with interplanetary dust creates natural particle sorting systems that organize cosmic materials according to physical properties throughout solar systems. These electromagnetic classification mechanisms operate through radiation pressure effects that separate particles based on size, density, and optical characteristics, creating organized dust distributions that persist for millions of years. The resulting material organization demonstrates how electromagnetic forces naturally create structured environments in interplanetary space. Some planetary ring systems develop such remarkable self-organizing properties that they automatically maintain optimal particle distributions through collective gravitational and electromagnetic interactions spanning billions of individual particles. These natural organizational systems demonstrate how large numbers of small objects can coordinate their behavior to maintain stable, aesthetically beautiful structures without central control mechanisms. The mathematical precision of these collective behaviors creates ring systems that can repair themselves after minor disruptions while preserving their elegant geometric arrangements. The gravitational resonances between multiple planetary systems create natural timing mechanisms where orbital periods align in mathematical relationships that repeat across cosmic timescales. These celestial chronometers operate through gravitational interactions that lock astronomical motions into precise temporal relationships, creating natural calendars that measure time with extraordinary accuracy. The mathematical beauty of these orbital harmonies demonstrates how gravitational forces create cosmic timing systems that persist across geological ages. Many atmospheric circulation systems achieve such perfect efficiency that they operate like planetary-scale heat engines, converting temperature differences into organized atmospheric motion that redistributes energy with minimal loss. These natural atmospheric engines demonstrate optimal thermodynamic efficiency, using thermal gradients to drive circulation patterns that maintain climate stability across geological time. The resulting atmospheric motion creates environments where temperature distributions remain uniform and weather patterns follow predictable cycles. The electromagnetic coupling between planetary magnetic fields and atmospheric ionization creates natural electrical generation systems that produce organized electromagnetic phenomena through atmospheric motion in magnetic field environments. These natural atmospheric generators operate through the movement of ionized atmospheric gases in planetary magnetic fields, creating electrical effects that follow predictable patterns based on atmospheric dynamics. The resulting electromagnetic phenomena demonstrate how atmospheric physics and planetary magnetism naturally collaborate to create electrical activity on planetary scales. Some worlds develop such perfectly balanced geological recycling systems that surface renewal processes operate at optimal rates for maintaining planetary habitability across billions of years. These natural geological maintenance systems ensure that planetary surfaces remain chemically active and geologically dynamic through tectonic and volcanic processes that follow predictable cycles. The resulting geological activity maintains optimal surface conditions without experiencing destructive catastrophic events that might sterilize planetary environments. The way certain planetary water cycles achieve perfect balance demonstrates how hydrological systems can maintain optimal moisture distribution across planetary surfaces for geological time periods. These natural irrigation networks operate through evaporation and precipitation patterns that automatically adjust to maintain ideal hydration conditions for surface chemistry and geological weathering. The mathematical precision of these water distribution systems ensures that surface processes proceed under consistently optimal moisture conditions. Many solar systems contain gravitational environments where small objects find natural parking spaces in stable orbital zones that persist for billions of years without requiring orbital maintenance. These gravitational safe harbors arise from multi-body interactions that create regions of enhanced stability where delicate objects can remain undisturbed across cosmic time. The mathematical elegance of these stable orbital regions demonstrates how complex gravitational systems naturally create protected zones for smaller objects. The thermal properties of certain planetary materials create natural temperature buffering systems that automatically adjust heating and cooling rates to maintain stable internal temperatures regardless of external thermal variations. These natural thermostats operate through material properties that respond to temperature changes by altering thermal conductivity and heat capacity characteristics. The resulting thermal regulation ensures that internal planetary temperatures remain within optimal ranges for geological activity and magnetic field generation. Some atmospheric chemical systems achieve such perfect equilibrium that reactive gases coexist in stable ratios for billions of years through natural regulation mechanisms that automatically maintain optimal molecular concentrations. These atmospheric homeostasis systems operate through chemical feedback processes that respond to concentration changes by initiating corrective reactions that restore chemical balance. The sophistication of these natural chemical control systems ensures that atmospheric compositions remain optimized for complex chemistry throughout planetary evolution. The electromagnetic interactions between multiple planetary magnetospheres create natural charged particle highway systems that organize cosmic radiation into structured flow patterns spanning interplanetary distances. These natural particle transportation networks demonstrate how magnetic field interactions can create organized radiation environments that remain stable for extended periods. The resulting electromagnetic architectures show how magnetic forces naturally organize charged particle populations into efficient transportation systems. Many worlds achieve such perfect atmospheric optical properties that they create natural greenhouse effects operating within precisely controlled temperature ranges that maintain optimal surface conditions for complex chemistry. These atmospheric greenhouse systems regulate planetary temperatures through selective electromagnetic radiation interactions that automatically adjust heating efficiency based on atmospheric composition. The spectral precision of these natural optical systems ensures that surface temperatures remain within narrow ranges suitable for liquid phase chemistry. The way planetary core convection systems interact with rotational dynamics creates natural electromagnetic power generation that converts mechanical energy into magnetic field energy with remarkable efficiency and stability. These planetary electromagnetic generators operate through magneto-hydrodynamic processes that automatically optimize energy conversion based on rotational conditions and thermal gradients. The resulting magnetic field production demonstrates how planetary interiors naturally evolve toward optimal electromagnetic generation configurations. Some solar systems develop such sophisticated cosmic ray management that their inner regions maintain stable radiation environments for billions of years through coordinated electromagnetic shielding operating at multiple scales. These natural radiation protection networks combine stellar magnetic fields, planetary magnetospheres, and interplanetary electromagnetic structures to create comprehensive cosmic radiation management systems. The effectiveness of these multi-layered protection mechanisms ensures that sensitive chemical and potentially biological processes can proceed in stable radiation environments. As we drift toward the completion of our gentle cosmic voyage, we find ourselves enveloped in profound evidence of the universe's infinite capacity for creating environments of extraordinary beauty and enduring tranquility. These stellar neighborhoods reveal themselves as masterworks of natural harmony, where mathematical precision and physical elegance collaborate across unimaginable spans of time to craft oases of stability that persist through cosmic ages. The gentle rhythms and perfect balances we have discovered remind us that the cosmos operates not through chaos and conflict, but through patience, precision, and an underlying order so profound that it transforms our understanding of what peace and permanence truly mean in the infinite symphony of existence that surrounds us on every side. The way certain planetary atmospheric compositions achieve perfect molecular equilibrium creates environments where chemical reactions proceed at their optimal rates for billions of years without disruption. These natural chemical laboratories operate through feedback mechanisms that automatically adjust reaction speeds based on molecular concentrations, ensuring that essential atmospheric processes continue at steady rates regardless of minor external changes. The precision of these molecular balancing acts demonstrates how atmospheric chemistry naturally evolves towards stable configurations that can sustain complex chemical cycles across geological time. Many worlds develop such perfectly synchronized magnetic field orientations that their electromagnetic protection systems align optimally with stellar wind patterns, creating maximum shielding efficiency that persists for cosmic ages. These natural electromagnetic umbrellas operate through magnetic field configurations that automatically orient themselves to deflect incoming charged particles most effectively. The resulting radiation protection remains stable despite gradual changes in stellar magnetic field strength or solar wind conditions that might otherwise compromise planetary electromagnetic defenses. As we complete this peaceful journey through the cosmic neighborhoods that surround us, we find ourselves filled with a profound sense of wonder at the universe's remarkable capacity for creating environments of enduring beauty and mathematical harmony. From the gentle giants that protect smaller worlds to the crystalline precision of planetary formation, solar systems reveal themselves as masterworks of natural engineering, where physical laws collaborate across billions of years to maintain conditions of extraordinary stability. These stellar arrangements remind us that even in the vast emptiness of space, order and tranquility prevail, operating on scales that transform our understanding of what permanence truly means in the infinite symphony of existence.